All right, everyone, let us start. So before we jump directly on Cisco SD-WAN, let us try to understand what exactly is SD-WAN all about and what is the concept of software-defined networking. So software-defined WAN, we have software-defined WAN, we have Cisco ACI, and we have Cisco SDA. Okay, we also call it as DNA. Basically, Cisco deals with three different types of technologies when we talk about software-defined networking. So trying to understand what is software-defined networking over here. Probably you guys might be aware of this. We are trying to segregate or abstract the control plane, the data plane, and the management plane from the device. So any networking device, if we talk about a router or a firewall, a router or a switch, any networking device will basically have three types of traffic associated to it. We have control plane traffic. If you try to compare control plane traffic from routing point of view, it's nothing but your routing protocols. We have BGP, we have OSPF trying to talk to each other. That's nothing but control plane. Similarly, if you talk about data plane is nothing but your actual VLAN traffic coming from the users. Management plane is your out-of-band management traffic, SSH, Telnet, SNMP. So every device basically has got this three type of traffic, that is control plane, data plane, and management plane. Now, when you say software-defined networking, what we are trying to actually achieve is we are trying to abstract the control plane and the management plane out of the device. So we are pulling out the control plane, we are pulling out the management plane from the box, and we are placing it on a separate controller. Now, this controller that we are going to use for SDN can be a hardware or it can be a software. That depends from vendor to vendor. So some of the vendors probably might use a hardware controller, other vendors might use a software controller. But the underlay concept and the reason behind coming up with SDN remains the same. That is to abstract your control plane and management plane and place it on a separate controller and have a controller-based management approach, right? So in today's world, we are basically having a huge infrastructure coming up. We have huge data centers, we have huge enterprise networks where configuring and managing each and every device becomes really difficult. We do have certain monitoring tools which allow us to monitor the devices from a centralized dashboard. We do have some third-party applications as well, which allow us to configure the devices from a centralized dashboard. But these monitoring tools and these dashboards do not give us a complete in-depth insight and that level of abstraction which basically a OEM can provide us, right? So Cisco came up with this approach of SDN back in 2013-14. They started selling Cisco ACI. That was the first software-defined solution from Cisco, which was designed for data center networking. Gradually down the line in 2016-17, Cisco acquired an organization known as Viptela, which was basically a WAN solution, a SD-WAN solution organization based out of San Francisco. And they relabeled the solution as Cisco SD-WAN Viptela, slowly introduced this in Cisco ISR, ASR routers. And somewhere in 2017-18, Cisco came up with a product known as Cisco SDA, Software Defined Access, which is basically a campus solution for software defined networking. So as of today, Cisco has got three different solutions: SD-WAN, ACI, and Cisco DNS Center. Right, all these three are SDN approach. And all these solutions are revolving around the same concept where we are abstracting the control plane, the management plane out of the device, and then we are having a controller-based management approach, right? So today we are here for discussing the SD-WAN solution from Cisco. Now talking about what exactly is SD-WAN. So like I mentioned, SD-WAN is not Cisco's original solution. It was Viptela organization, which was acquired by Cisco. So Viptela introduced a SD-WAN solution somewhere in 2015-16, and then it got acquired by Cisco couple of years itself. Now, Viptela basically had the approach of software controllers. So the SD-WAN approach adapted by Cisco is the same approach which was taken by Viptela. We don't have any physical hardware. We don't have any new routers introduced by Cisco. So we are basically managing the same WAN routers. Now, when you say software-defined WAN, so WAN itself is nothing but Cisco ISR, Cisco ASR, Cisco CSR routers, right? We already had these routers running in production from Cisco since last 2 decades almost. Like more than 20 years, Cisco is selling ISR, ASR routers, and it is doing really good. And now when you say software-defined WAN, so these same series of routers which were introduced by Cisco since last 2 decades are now being configured and managed through a controller. So if you are trying to imagine what exactly SD-WAN is all about, it's nothing but managing your Cisco routers, the same routers which you guys have been working on since very long, through a controller-based management, right? So that is basically, in short, what is SD-WAN? Controller-based management for your Cisco routers. Now, in addition to this, like, so if you go to a customer and if you sell SD-WAN as a solution to a customer, and you're going to say that, okay, we are going to allow you to manage your routers from one single controller. So customer will be like, okay, fine. What is more? Like, why do I want to buy Cisco SD-WAN? I don't want to buy the solution just for managing it through a controller. What is more about it? So in addition to having a controller-based management approach, another major advantage of Cisco SD-WAN is application visibility. So if you talk about Cisco SD-WAN, one of the major advantage apart from a standard adoption of controller-based management is application visibility, which was not available until now in any other routers. So if you talk about a router, let us say I bring in a Cisco ASR or I bring in a Cisco ISR router, and now this ASR or ISR router is connected to one of the branch offices, and I have a lot of traffic going out from this router. I have voice traffic, I have YouTube, Facebook traffic, I have my FTP traffic, XYZ or www HTTPS traffic. A lot of traffic going in and out from this router. Now, ideally, if you try to understand ISR or ASR routers, do not support the concept of deep packet inspection, right? They do not support deep packet inspection. They do not have the advantage of application visibility. So whenever we have any kind of traffic going out of a router, we do not have the privilege of verifying what kind of traffic it is. We cannot identify the traffic. What we can do at max is we can configure QoS. We do configure QoS based on the DSCP values. We try to match the voice traffic, and we provide a proper QoS to voice. We do try to match some traffic on the basis of access list. We do policy-based routing, right? So there is no option on the existing setup to verify what kind of traffic it is and how do you want to forward the traffic. So traffic engineering was another advantage, which was a limitation in the previous solution, and now we have it as an advantage in Cisco SD-WAN. So in similar way, there are many more advantages which we have with regards to Cisco SD-WAN. One of the advantage, application visibility. Another advantage is controller-based management, and so on, right? So in a nutshell, when you say software-defined WAN, from Cisco's point of view, what we are trying to achieve is we are trying to manage Cisco routers, ISR, ASR, CSR routers from a centralized controller. We have different types of controllers, which we are going to discuss shortly, but that is in a nutshell what Cisco SD-WAN is all about. Let us come back to the slide deck. So this is legacy WAN architecture, guys. Typically, if you talk about any organization, every organization will have a data center environment. They will have a DC environment, DC and DR. And this will be connected via two different types of transports. So we will have an MPLS backhaul link. We will have a backup MPLS. We might have internet as a transport. And then we will have multiple branch offices which are spread across different locations. So this is our typical architecture of a particular organization might look like. So if there is a particular branch who wants to communicate with any IaaS, infrastructure as a service, for example, we have certain applications running on AWS or Azure, or we have some software as a service applications. So for example, Office 365 or Salesforce or Google Cloud. So all these applications are always accessed from the branch via MPLS backhaul. So the branch offices will never have internet locally terminating over there, and from internet they will never access any IaaS or SaaS applications. Looking at the trend of how the applications are being deployed, having your applications on AWS or Azure or software as a service application is a very common requirement nowadays. And then for the branch users to access these applications by doing a hairpinning through a data center is very difficult. So if you have like 1,000 branches who want to access any IaaS or SaaS services, and if these 1,000 branches go over MPLS to the data center router, From there, they go to the internet firewall, and from there, they try to reach out the application. Then this is basically a longer path, right? So scalability, manageability, flexibility was a lot of, we had a lot of limitations in our existing infrastructure, right? Managing each and every router locally, not able to utilize multiple transports at the same time, not having local internet breakout for the branch offices. All these were basically limitations which we had in our existing or a legacy WAN architecture. And these limitations are now overcome by Cisco SD-WAN, right? So what Cisco SD-WAN allows you to do? Now, earlier days, everything, all the applications were basically hosted in our data center only. If we had IoT devices, if we had our campus and branch users, we had mobile users, all these different types of users were connected over the WAN network. This WAN could be MPLS or it could be internet. And then the applications were all hosted or were accessible through the data center only, right? We had our in-house applications running. Apart from that, we had applications of SaaS, applications of IaaS, and everything was backhauled via MPLS links. The traffic used to come to our data center. From data center, we used to provide an internet breakout, and from there, the applications were being accessed. But in today's world, the applications are not just spread in data center, but they are spread across different locations. So we have certain applications running on Azure, Google Cloud. We have certain applications of SaaS, Dropbox, Office 365. We have in-house applications running in our data center itself. And now we don't want to have the legacy approach of accessing these different types of applications through MPLS backhaul. We don't want the traffic. So if a user is sitting in branch, let us say I have a user sitting in my branch. Let us say this branch is in Mumbai. And now this user is in Mumbai and we have our AWS application. We have our application running on AWS cloud, which is basically somewhere in, let us say, San Francisco, right? And now my data center is in Bangalore. So the user typically does what? Over MPLS, the traffic will come via MPLS to my Bangalore data center. From Bangalore data center, I have a local internet breakout. So via firewall, the traffic will go to my DC firewall, internet firewall, and from via internet, it will now go to my AWS cloud. Now this is just for one branch. Imagine in the similar approach, imagine I have got like 1,000 branches spread across different locations across pan India. So the traffic of all these branches, traffic of all these branches will basically come via MPLS backhaul. Let us say this MPLS link is 50 Mbps link. So via this MPLS link of 50 Mbps at my DC head and side, I'm having all the traffic of my AWS application coming to me. And then I need to reroute this traffic through my internet firewall and then send it on the cloud, right? So there is a lot of bottleneck over here. We are overutilizing our MPLS just for all the applications running on AWS. We don't want this. We want the traffic to come from the branch. The traffic should directly have a local breakout of internet and able to access the AWS cloud, right? What if there is Office 365? So we have multiple applications running on SaaS and IaaS, and all this application traffic, I don't want to backhaul through my internet or through my MPLS cloud. So these kind of requirements where nowadays are very common requirements, and your legacy architecture cannot suffice or cannot hold this requirement. It cannot provide a solution to these requirements. And this is one of the major need of the next generation WAN solution, which is basically your Cisco SD-WAN. Now that's how your legacy WAN architecture looks like. So if you have like 100 routers spread across different locations, your 100 routers are basically going to have 100 different neighborships. So if you try to compare, let us say we have got 5 different locations connected via MPLS. And then I have my DC and DR kind of setup. So everything is connected via MPLS. Now in legacy WAN architecture, what do we have is we have our BGP peers established. We have our BGP peers getting formed over MPLS with our DC-DR routers, with our PE routers. And then every router is basically having its BGP neighborship established, and they're advertising their routes. And we are advertising our prefixes to our MPLS service provider. And MPLS service provider is charging you heavily for providing a link of maybe 2 Mbps or 4 Mbps, or at DC head and maybe 50 Mbps of link. We are paying heavily for this. to get a private connectivity of MPLS or your MPLS backbone network. What Cisco SD-WAN says is you don't require MPLS anymore. So Cisco SD-WAN is a transport independent solution. What we are trying to achieve in Cisco SD-WAN is instead of having a direct dependency of MPLS, Cisco SD-WAN is a transport independent solution, which means irrespective to what kind of underlay infrastructure you have, as far as your branch is able to communicate with your DC, it is having IP reachability, your branch and DC are having IP reachability, Cisco SD-WAN is going to establish its own tunnel on top of your underlay. So over MPLS, over internet, over P2P link, over 4G transport, any kind of underlay transport, on top of this underlay, we are going to establish our own overlay connectivity. We are going to establish our own overlay network, and we are going to advertise our routes. We are going to send our data traffic using this overlay tunnels. So Cisco SD-WAN basically establishes something known as DTLS, data transport layer or transport layer security, DTLS, TLS tunnels, and they create IPsec tunnels. DTLS, TLS connections are formed for control plane, and IPsec tunnels are formed for data plane. So whatever transport you are having, whether you are having your internet broadband connectivity, whether you have a P2P link from your service provider, whether you are using your 4G as a transport, or you are using your MPLS as a transport, your underlay can be anything. On top of this underlay, your routers are going to create a DTLS connection and IPsec tunnel. And using this DTLS connection, I'm going to advertise my routes. So all the routes of my LAN will be advertised to my branch, to my DC head and router using this secure DTLS connection. Similarly, all the data traffic from my branch will be forwarded to my DC head and router over a secure IPsec tunnel. Now, the good part about the solution is these IPsec tunnels and these DTLS connections get created dynamically. So you don't need to configure these tunnels manually. You don't need to configure IPsec tunnel. You don't need to establish DTLS connection manually. As soon as your router gets onboarded, automatic tunnels will be created and your control plane and data traffic will be forwarded, which means that now if today you are paying, for example, I'm paying almost $100K to my MPLS backbone service provider for providing me a 2 Mbps link across my 100 locations. If I migrate to Cisco SD-WAN, I can just pay $10,000 for my broadband connectivity of 1 Gbps across all the 100 locations, and I can utilize my internet as a transport. So you can utilize your internet as a transport. You can utilize your 4G as a transport. So no need to pay your heavy charges for MPLS or a P2P link for connectivity between your branch and your DC locations. Using any kind of underlay, my SD-WAN will build its own overlay and will securely send my control traffic and my data traffic across the network. Another good advantage of Cisco SD-WAN is you don't need to form neighborship with your BGP. So in your earlier transport, in your earlier legacy WAN architecture, what we did was we used to basically have a complex neighborship and complex configurations of BGP with our PE routers, right? So maybe this is your CE router, branch CE router. You're getting connected to your provider edge routers of MPLS. And now what you do over here is you try to configure BGP and you try to configure BGP attributes, right? You configure BGP attributes where you are defining that I want this as primary, I want this as backup, return traffic should come from here, return traffic should go from there, and so on. And we had a lot of BGP configurations. We used to configure access list, and we used to try to filter out the routes so that all the routes do not get advertised. And there was a lot of complexity over here, right? Now, this complexity is completely wiped out. You don't need to worry anything about BGP anymore. Why? Because you're not advertising anything on your underlay. So even if you are going to use MPLS as a transport for your network, this MPLS will be purely providing you IP reachability. You don't need to advertise any routes on the underlay. You don't need to learn any routes on the underlay. My underlay will be purely used. My underlay will be purely used as a transport. So No configurations of BGP. You just need to follow a normal neighborship. No need to advertise anything at all. Everything will be advertised using the overlay tunnels which are getting created in the network. Guys, just excuse me, I'm getting a call, please. So basically your underlay transport of MPLS will be purely used for IP reachability, and you do not require any more complex configurations of MPLS and so on, right? Another advantage in SD-WAN is SD-WAN basically has its own controller. So all the branches which we have in SD-WAN on all the head-end routers, they do not need to form neighborship among themselves. So we are not going to establish our neighborship with our branch to branch routers or branch to head-end routers. All these neighborship will be formed with a centralized controller. So the controller basically will basically act like a more or less like a BGP route reflector. So just like in BGP route reflector, to avoid that full mesh in BGP and to avoid that IBGP neighborships, what we do is we configure a BGP route reflector and we just tell our routers to talk to our BGP route reflector for advertising any routes. Similarly, in Cisco SD-WAN also, we have a centralized controller which will be responsible for advertising all the routes. So if branch 1 needs to advertise any route to the other branches or to DC and DR, branch 1 does not need to advertise the routes to everyone and form neighborships with all the routers. Branch 1 will have just one neighborship with a centralized controller, and I will advertise this route to the controller. And then controller will be responsible for further publishing these routes to all the other routers with the next hop set as your branch 1, right? So the controller is basically simplifying your routing on the network. You don't need to advertise the routes to each and every router. You don't need to worry about forming neighborship with each and every router. You are just going to form neighborship with your controller, and controller will take the responsibility of having the routes advertised to the rest of the fabric participating in your SD-WAN network. So in Cisco SD-WAN, we basically establish secure tunnels. We are segregating our control plane and data plane. So my control plane and data plane will be separated. My DTLS connections will be created for control plane. So the routers are going to establish a secure DTLS connection with the controller. So these green color lines you can see are basically my control plane communication, which is happening with my controller over internet, over MPLS, over 4G. So any kind of transport you can choose from to establish your control connections. And then my data traffic will be from router to router directly. So the black color segments you can see over here are nothing but your IPsec tunnels, which are getting created between the router for data plane communication. So my data traffic will go from one router to another router directly, depending on the route from where it is getting learned. And my control plane communication will go to the controller only, right? So my control plane is DTLS connections, which is with the centralized controller, and data plane traffic is from router to router. So that's how basically we are segregating our control plane and data plane. So router to router, we do not have any control plane. Router to router is just your data traffic, and control plane and routing updates is with your centralized controller.
Yeah, Rajiv, sorry to cut, but let's see my client have, legacy network. They are using ASR or ISR. Now they are moving to the SD-WAN. So what they should do? I mean, they need to some licensing to install in ISR to support SD-WAN or any feature.
Yeah, so basically when you are trying to migrate your existing routers from non-SD-WAN to SD-WAN, you need to buy the licenses. You need to go on Cisco Smart Account portal, and over there you need to register your devices, provide your serial number of the devices, and add them in your smart account, and let Cisco know that these are the boxes which we are. So hardware will remain the same. You just need to pay additionally for the number of routers that you are converting from non-SD-WAN to SD-WAN. I will be speaking about the licensing part. There are a couple of factors in that, depending on the bandwidth and depending on the pricing model. We have 3 different models of licensing tiers. I will talk about that, Devinder, probably in the second last or last class when we talk about how we do licensing in Cisco SD-WAN.
Yeah, sure.
Yeah. But yeah, for answering your question, we can convert an existing router of non-SD-WAN, ASR to SD-WAN. It's not mandatory to buy a new box only. You can convert your existing routers to SD-WAN as well, as far as they are hardware compatible.
Okay, thank you.
All right. Okay, so let us quickly talk about what are the different features and advantages of Cisco SD-WAN. So like I said, Cisco SD-WAN is not just about a centralized controller management approach, right? It's not just about providing you a centralized controller from where you are doing your centralized management, you are doing your centralized control plane routing. No, it's a lot more. So what are the different features we have with regards to Cisco SD-WAN? Some of them probably might be used by you as well, where you are pitching in SD-WAN as a solution to a customer. The first advantage we have is application-centric networking. So like I mentioned to you guys, one of the major advantages of Cisco SD-WAN is it allows you to do application visibility, right? Which means, yes. Is there a question? Maybe you can go on mute, Devendra and Mir, if you don't have any questions.
Rajiv, I cannot see the screen is showing in a blank. Only for me.
I'm sorry, Mir, you're not audible to me.
Yes, right now it's okay. Rajiv, you can.
No, your audio is really low. Maybe you can try to disconnect and connect back.
Okay.
All right. So application-centric networking, guys, that is the first advantage we have at Cisco SD-WAN. Now, the legacy routers which we had in in non-SD-WAN did not support the concept of deep packet inspection. So DPI was until now available only on your firewalls and your load balancers, right? Your DPI was not supported by any routers or layer 3 devices. But Cisco SD-WAN adapts the approach of deep packet inspection, which means it's going to open the packet up to layer 7. It's going to open the packet from layer 4 to layer 7 headers and take a look at what exactly the packet is about, whether the packet is for a YouTube traffic, a Gmail traffic, a FTP traffic, or regular browsing. And depending on the identification, whatever policies are being configured, so you can define the policies. For example, I can say that whenever the traffic is for YouTube or Gmail or Facebook, the traffic should exit via broadband internet link. If the traffic is for my internal application, then the traffic should go over MPLS. If traffic is for cloud service provider, then it should go via 4G transport. So your SD-WAN router will allow you to perform a deep packet inspection where you can verify what kind of traffic it is. Accordingly, you can design the policies, and you can also try to meet your SLAs. So you can say that whenever the traffic is for voice or video, I want the latency should not go above maybe 50 milliseconds. My packet drop should be not more than 2, and my jitter should not be above 5. For example, if I have my critical traffic of banking application, then latency should not go above 80. My packet drop should be 0, and my jitter is not coming into the picture. So you can try to define the SLA requirements as well. And then on the basis of this SLA, whichever transport is giving you the best performance, your SD-WAN will automatically choose that particular transport, right? So once you identify what kind of application it is, what kind of traffic it is, you can try to define a policy to choose a particular transport. You can try to define your SLA requirements. You can try to send the traffic directly on your cloud, maybe your AWS, Azure, or SaaS application traffic. You can do a local breakout. You can send the traffic, instead of sending the traffic on your IPsec tunnel overlay network, you can send the traffic on your broadband internet directly, maybe a YouTube traffic or Facebook traffic. You can do a DIA, direct internet access, right? So instead of backhauling the traffic of YouTube and Facebook via data center head and router, you can directly do a DIA and you can send the traffic directly on the internet. You can do service chaining where you can reroute the traffic through a firewall. So there are multiple options which are available once your router identifies what kind of traffic it is. So one of the major advantages of Cisco SD-WAN is it does application-centric networking, where you can identify what kind of traffic it is. And on basis of that, you can forward the traffic on the network. Another advantage of Cisco SD-WAN is that flexible WAN connectivity, or you can say bandwidth augmentation. So one of the limitation we had in earlier solution was if I had two MPLS links, okay, I had MPLS backbone from Airtel and I had MPLS backbone from Vodafone. I had two service providers. Now, legacy WAN routers did not support active-active concept, right? which means I always used to use my uplinks as active standby. Okay, so if the traffic is coming from the branch, I will basically configure my Airtel as my primary backup, primary MPLS service provider, and Vodafone as my standby service provider. So all traffic will go out from Airtel, come in from Vodafone, or go out from Airtel, come in from Airtel, or however we wanted, right? So we could not basically leverage all the uplinks at the same time. There was no way of utilizing all the uplinks at the same time because there was no load balancing done, since these were two different service providers, right? So configuring, so even if I had multiple service providers on a particular branch, I could not leverage the multiple MPLS links at the same time. And this is what Cisco SD-WAN does. So basically, Cisco SD-WAN is creating its own IPsec tunnel on top of your existing underlay network. And because it creates its own IPsec tunnel on existing underlay network, Cisco SD-WAN allows you to do ECMP, equal cost multipathing, or you can say load balancing. So you can have multiple uplinks utilized at the same time. For example, I'm having my DC head and router. Here I have a route of 10110/24. I have my certain applications running in this prefix, and my branch user wants to communicate with this application running in my DC. So now my branch router will see that this particular route of 10110 is available behind my DC head and router. And to reach my DC head and router, I have three different kinds of tunnels. I have three different kinds of transport. I have MPLS, I have 4G, and I have internet. So what branch router is going to do? It's going to do load balancing. First packet from here, second packet from here, third packet from here. So all the links will be utilized at the same time, right? Which means that you are basically having a better bandwidth augmentation done. You are basically able to utilize your multiple links at the same time. So my internet link and my MPLS link. MPLS is my private connectivity, internet is my public connectivity. On both the links are being utilized at the same time to reach out the application which is actually running in my data center. So without SD-WAN, there's something on the chat. No, Mir. It cannot be done via PBR, right? Because internet is open internet connectivity. You cannot utilize internet as a transport in non-SD-WAN. So from branch to your DC, you cannot communicate via internet. You cannot publish your routes on internet, right? You can only publish your routes over MPLS. So if you try to compare this with legacy architecture, MPLS, 4G, and internet, if it was used in legacy architecture, you could have reached your private data center application only via MPLS, because only that is where you are able to publish your routes and you are able to utilize the transport. You could not reach the same application over 4G or internet, because 4G and internet are open networks. You cannot advertise your prefixes. But in Cisco SD-WAN, because we are building our own tunnel over internet, over 4G, and over MPLS, we can leverage all the three transports at the same time, right? So that is nothing but another advantage of Cisco SD-WAN, that is bandwidth augmentation, able to utilize your multiple transports at the same time. We also have the concept of zero touch provisioning. So what is zero touch? Yeah.
Yeah, we can achieve this via site-to-site VPN, right? Normally, site-to-site VPN, so one branch and multiple location.
That's right. We can configure our IPsec tunnels. We can configure our VPNs, and we can do that. But again, configuring your IPsec tunnels and configuring VPN was a manual job, which was done in our legacy network. And we do have the option of DM VPN as well, where we configure DM VPN over different transports and we leverage it. But in that, again, your ECMP was not a inbuilt functionality, right? You could not configure it as a inbuilt functionality. IPsec tunnels are providing you the secure tunnels. More or less, we are doing the same thing in SD-WAN as well. We are creating automatic IPsec tunnels over internet, over 4G. And the job of ECMP is an inbuilt functionality in SD-WAN. So we don't need to configure any explicit routing for providing this functionality. So as soon as your router creates a tunnel, it automatically identifies the DC head and router, and it creates the tunnel and it publishes the route. So the things are automated, Vinshit, you can say. In IPsec tunnels, we used to configure tunnels first, then enable routing in the within the tunnel and then advertise our routes, and then we were able to leverage that multiple paths. In SD-WAN, it is an automated process.
Okay, okay.
So Rajiv, you said that it is load balancing. I mean, it is utilized for all of the underlays, like whether it is MPLS, 4G, and internet, while transferring the data to the data center, right? So what if, meanwhile, if I am transferring data to the data center and suppose my internet goes down, what about those packets which are
You will
going
see
via
a,
internet?
so that particular transport, if it becomes unreachable, then it's like one of the link is down. So the traffic will then load balance across the other links. You might see a 1 or 2 packet drop for that particular link, since the packet was already sent on that link. That packet is dropped. But we do have an option in Cisco SD-WAN for packet deduplication. For critical applications, you can enable packet deduplication so that the packet will be duplicated and sent across multiple links at the same time. So even if one link goes down, the same packet is being sent to the other link as well. So you will have a 0 packet drop on the network. So for any critical applications, Cisco supports the concept of packet deduplication. So for applications like ATM transactions or credit card transactions, especially BFSI sector, you can enable packet deduplication functionality. It's one of the feature in Cisco SD-WAN for having a 0 packet drop tolerance policy.
So we will study this.
Yes, it will come in
Okay,
upcoming
no
slides.
worries. Thank you.
Another question in the chat from Mathura: what is the routing protocol underneath? Yeah, so Cisco SD-WAN uses its own proprietary protocol, Mathura, that is known as OMP, Overlay Management Protocol. So OMP is the protocol which is basically providing you the routing inside the overlay network of Cisco SD-WAN. So on top of MPLS, 4G, and internet, we are having our secure DTLS connections getting created. Inside these DTLS connections, we are running a Cisco proprietary protocol known as OMP. It will come in the upcoming slides, which is helping you to advertise the routes and provide you the reachability across the network. All right. So coming to zero touch provisioning. Now, this is one of the most important advantage as well. Cisco SD-WAN supports the concept of zero trust and zero touch provisioning. What does it mean? Yes.
Just go back to Sila. Yeah. Let's say if you have the 3 underlay networks, so the branch router create 3 tunnel. Based on how to control this tunnel creation. So let's just now I mentioned branch router. Let's say MPLS and 3G and internet. The branch router create 3 tunnel to the data center router, right? So it will control by the controller, or the router itself automatically create the tunnel?
Router automatically creates the tunnel as soon as it receives the information of the available transport. So for example, let us say I'm onboarding this branch router. This branch router joins the controller.
Yes.
Right. So as soon as I join the controller, I'm going to advertise that I have 1 MPLS and 1 4G interface. Similarly, DC router also will advertise that I have 1 MPLS, 1 4G, and 1 internet interface. So when this router joins the network, controller will advertise to the branch that we have a DC router who has got these 3 interfaces. Then I will verify which my local interface is able to reach the remote interface, and whichever has the IP reachability, the tunnels will get created automatically. So you don't need to provide the information, or you don't need to manually initiate a tunnel. I will receive the updates of the different other routers who are part of the network, and the different transports they have locally with them via controller. And once I receive that information as a route, I will automatically create a tunnel.
Oh, okay.
Right. So this process is taken care by OMP.
Oh, yeah. Okay.
So it will come in the upcoming slides.
Okay.
So Rajiv, so I think we can say that the branch routers, let's assume those are dummy devices. They are only depends on the controller. Whatever controllers say, they will do. As of
right.
Okay.
Correct.
Thank
So
you.
all the intelligence is with the centralized controller, since the control plane is with the controller.
Yeah.
Okay, so one more advantage we have is zero touch provisioning, guys. Now, what is zero touch provisioning? Imagine you are setting up you are having a refresh, a tech refresh for a particular customer. Customer was using some old routers, and now customer is planning to do a tech refresh for 1,000 sites across pan India, right? And in this tech refresh, you are supposed to replace your ISR router. A customer was using ISR 1100 model, and he wants to replace this with a newer model, let us say ISR 4K, right? And this tech refresh is for 1000 sites across pan India. Now imagine if you are planning to do a tech refresh for such a large number of sites, you need to send a field engineer on each and every site. That field engineer will remove the old box, add the new box. He will provide you the remote console access. You will replace the configuration. You will verify the connectivity, and you will onboard the device, right? So basically, for 1000 sites, you will have to do the configuration 1000 times. Every branch location, your field engineer should go. He should be aware about what is a console port, what is a management port, how to do the physical connectivity. There has to be a field engineer who is having some basic routing and switching knowledge. You cannot just send a layman guy and tell him that, okay, just connect this router and the router will come online. It's not possible. He will provide you a remote access via Cisco WebEx, and then you are going to do some basic configuration, IP addressing, and run a configuration of BGP on it. If there is a DM VPN configuration, then you will configure your VPN configurations on that router, and then you will onboard the router. So it becomes a really hectic job when you're planning to do a tech refresh, or when you're trying to migrate your routers from older boxes to newer boxes, right? But with Cisco SD-WAN, this is not a problem at all, because in Cisco SD-WAN, we support the concept of zero touch and zero trust provisioning. Now, what is zero touch and zero trust? It's basically automatic router onboarding. It's automatic router onboarding, which means that once the router is shipped by Cisco, you can automatically onboard the router. You just connect the router to the power supply and connect the router to a network. Now, this network can be a MPLS or it can be open internet. As soon as the router is connected to the power supply and to internet, this router has got an inbuilt chipset known as TPM, tamper-proof module, which contains the certificates, and there is a bootstrap configuration given by Cisco as a factory default setting. And in this bootstrap, this router will be trying to communicate with a controller. So as soon as you connect the router to the network, router will boot up, and using this bootstrap file, it will go and talk to the controller, right? We will talk about what is this controller and how this exactly works. Right now, I'm just showing you a brief overview. So as soon as the router boots up, it will go to the controller. From controller, I will get the details and the configuration file, and the router will be onboarded automatically. So without taking any console access, without doing any manual configuration, the router will be automatically onboarded, right? So this approach of dynamic onboarding or automatic onboarding of router in Cisco SD-WAN is known as PNP, plug and play functionality, or in other words, we call it as ZTP, zero touch provisioning. So as soon as you boot up the router will use the bootstrap file, go and talk to the controller. Controller will identify the router using the certificates, which are based on the TPM chipset, and will push the configuration on the router, right? So this automatic onboarding of the router is known as plug and play functionality or zero touch provisioning in Cisco SD-WAN. This is a very wonderful concept, and we are going to actually talk about this in complete detail, how exactly we achieve this. This is just a broader picture of what zero touch provisioning is, right? So zero touch provisioning is automatic device onboarding. So this is possible in both the cases where you have open internet or where you have MPLS backbone. So it's possible even for the branches which do not have internet, and it is possible for the branches which do have internet as well. So in both the cases, you can automatically onboard the routers, and this basically allows you to do the router onboarding within few minutes instead of few hours, where you are going and trying to synchronize with the on-field engineer, he providing you the console access, you taking the remote access, doing the configuration manually, and then onboarding the router, which obviously takes few number of hours. Within few minutes, as soon as the power supply is connected and the router gets an IP address via DHCP, or you configure it statically, the router can be onboarded automatically, right? So this concept is known as zero touch provisioning. There's a question in the chat. We need to configure PPOE connectivity or internet. Like I said, Mir, it is possible in both the cases. either you have a PPOE link, or you have internet, or you have MPLS backbone. In either of the cases, it is very much possible, right? We are going to study this concept of zero touch provisioning in complete depth, guys. It is a very wonderful functionality, and I will cover it in a very nice way. Okay. For now, you can just make a note of this point, that zero touch provisioning or plug and play functionality is nothing but automatic device onboarding of the router. Okay. All right, going to the next. Yeah.
This controller should be a hardware or it's a software, anything?
It's a software. It's a software basically that you're talking about this one, Vinchit, right? The controller in zero touch provisioning.
Yeah, correct.
It's a software controller. Cisco does not have any hardware controllers for SD-WAN solution. They're all software controllers.
Do we need to configure any public IP or anything like that?
Yes, of course. We should have a public IP address for the controller to be made reachable over internet as well. So if you don't want the controllers to be reachable over internet, then you can just have private IPs. But if you are going to use internet as a transport for your network, then you do need to make sure that the controllers are reachable over public IP address as well.
So Rajiv, one question here, that like in ACI, Cisco recommend 3 controller, right? That is 3 Epic controllers. So here, is there any recommendation from Cisco?
Yes. We are going to shortly talk about the controllers. We have 3 different types of controllers, guys. We have something known as vManage, we have vSmart, and we have vBond. There are 3 different types of controllers. And for redundancy, we do host multiple controllers of the same type. So we host like 3 vManage, couple of vSmarts, and couple of vBonds for sake of redundancy.
Okay.
Yeah. All right. Another advantage. So currently we have not started yet with the types of controllers and what are the different controllers and what is the purpose of it, right? Currently we are just speaking about the different advantages of Cisco SD-WAN, and then we will come to the architecture.
Sorry, sorry disturbing you because I connect my mobile again. So
yeah,
actually one question is there. Basically some confusion is there. You said the controller is only software based.
Right.
What about the SD-WAN CPE? Because this is the little bit confusion, because there are market, there are I think 3 or 4 types: CPE, universal CPE, SD-WAN CPE, and virtualized CPE. So what about the router point of view or customer end device?
Routers are hardware. Routers are hardware. So like I mentioned, your routers will be ASR, ISR. From hardware point of view, we have ASR 1K, we have ISR 1K, ISR 4K. We have virtual routers as well, CSR routers for cloud-based solution. So routers will be all hardware, but the controllers are software controllers. So controllers are we don't have any hardware controllers for Cisco SD-WAN. The edge routers, which will be hosted on the branch locations and the DC locations, will be our hardware boxes. But they will connect to the software controllers, which will be either hosted in your data center or they will be hosted on Cisco Cloud.
Okay, Rajiv, one more thing.
Yeah.
What about the white boxes? Is it
Not
Cisco
possible.
controller is supporting white boxes? Or
no, it has to be a Cisco hardware only. You cannot go with any other third-party hardware or any open box.
Okay. Second question regarding the zero touch. For suppose if we are using the same router to establish the internet connectivity, I mean the PVP over e-dialer, or we have to configure some static IP address, DHCP, not enable is WAN connectivity.
Correct.
So in that case, zero touch will not.
In that case, you will require a console access for configuring a basic static IP. But apart from that static IP, as soon as static IP is configured and reachability is established, you don't need to do any additional configuration. So for the sites which do not have DHCP enabled, for example, you have a BAMPLS site or any other kind of site, PPOE site or any other site, a dial-up site where you require a static IP configuration, then the on-field engineer will require a console access where he takes the console access, configures the configures the IP address on the interface manually, and that's it. As soon as he configures the IP address on the interface manually and the router is able to talk to the controller, the router will get the rest of the configuration pushed up by the controller automatically. So no need to do
Okay,
additional
fine. Thank you.
configuration apart from basic IP address. Clear everyone, guys? All right. Okay, another good advantage of Cisco SD-WAN, that is secure segmentation. Now, we all know that in legacy architecture, what we did was for segregating the routes in legacy architecture, we used to configure VRF, right? We used to configure a guest VRF, maybe IT VRF, management VRF, and so on. And these VRFs were basically used for segregating your routing table, for segregating the routing table and for segregating the data traffic. But the scope of this VRF was applicable up to your branch only, correct? For example, if I come back to the whiteboard, so this is my branch router. This is my branch router. Here I have guest VRF, I have IT VRF, I have management VRF. Now this customer edge router gets connected to the PE. Now once the packet goes to your PE router, all these routes are part of the same single VRF, which belongs to this customer itself, right? PE router will not segregate your routes on per VRF basis. And then when the router comes back to this network over here, we basically configure route targets and RD values to again import the routes into specific VRF according to our requirement, right? So what I'm trying to say is there was no end-to-end concept of segmentation available in your legacy routers. As soon as the packet leaves your router, everything is part of a global routing table or a single VRF on the PE side. So some MPLS service provider does not segregate the routes on per VRF basis, which was done by you at your branch side, which means the segmentation which was done in your legacy WAN network was limited to your branch only. The segmentation was not possible in end-to-end way. But in Cisco SD-WAN, we have the concept of end-to-end segmentation, which means when a router in Cisco SD-WAN creates channel with the other side router, my segmentation which I have done on the branch side, the transport towards your DC head and router as well. 1 second, it looks like my internet is a bit unstable, guys. Let me switch over my internet. Am I audible or am I choppy?
Audible now.
Okay, I thought that my internet was broken. Anyways, if I'm not audible, then let me know, guys. Yeah, so what I was saying is Cisco SD-WAN supports the concept of end-to-end segmentation, which means that here if I configure VRF guest, VRF IT, and VRF management, you cannot basically configure the names. You can say that VRF 10, 20, and 30, something like this. So now this VRF tag will be added inside your IPsec header. So in my IPsec header, I will add a field of VRF 10. So when the packet leaves my network, my branch, it will go with a tag of VRF 10 across the transport. And when it reaches your DC side, the packet will be allowed to exit on VRF 10 only. So the guest user sitting in my branch will be able to access the guest portal at my DC only. IT guy in VRF 20 will be allowed to access the applications in VRF 20 only. Management users in VRF 30 will be able to access the applications of VRF 30 in DC only. So you are basically able to extend your VRF tags across your transport. That's nothing but end-to-end segmentation. So you can achieve end-to-end segmentation in Cisco SD-WAN, and VRF in Cisco routers is equal to VPN in Cisco SD-WAN concept. So over here, when you say VPN 1, VPN 2, VPN 3, that's nothing but VRF 1, VRF 2, and VRF 3. Okay. So here we call it as VPN, but this VPN is nothing but VRF in your SD-WAN, in your iOS routers. So Cisco SD-WAN allows you to do end-to-end segmentation, which means whatever VRFs or whatever segmentations we are going to do at our branch side, the same segmentations can be globally carried across multiple locations. So I can have the same segmentations done everywhere, and but traffic across the VRF by default is denied, right? So you don't need to worry about how the segmentation is going to work, because your VRF tags will be carried over the transport inside the IPsec header across different locations. That's another advantage we have with Cisco SD-WAN.
So Rajiv, this segmentation,
Maybe you can
is
mute
there
yourself on one side. Yeah.
okay, Rajiv, regarding the segmentation is the area wise or it is service wise?
I did not get your question, Mir. It's not.
Okay, for suppose the data services between one campus to another campus, there are some the voice is going from one campus to another campus. So if we say the one VPN tunnel is going, right? In the VRF case, we are making through the services type. Possible voice service, data service, some
Right.
firewall services,
Right.
or some what do you say?
So it will be, yeah, more or less in the same fashion. So my voice traffic, I am using VRF 10. My data traffic, I am using VRF 20. My critical applications are running on VRF 30. My guest users will use VRF 40, something like this. So you're going to segregate your traffic based on how you want to, how your applications are being bifurcated. So my voice applications, my voice traffic, my CUCM IP phone traffic will go on voice VRF 10. So I can apply a QoS for voice. My data traffic, regular data traffic will go on VRF 20. My critical applications, I can again configure some QoS. I can do some PBR, and I can do SLA based routing for this. So that traffic will go on VRF 30. And my guest users at the branches, they want to connect on self-service portal and they want to register themselves on the network. This all traffic will go on VRF 40. So you can segregate your routes and you can segregate your data traffic on per VRF basis. And the same tag will be carried across the branch and the DC. So all traffic coming from branch for IP phone which needs to get registered, the CUCM server is in my data center head and behind data center head and router. The traffic from my IP phone, when it connects on that particular VLAN, it will become part of VRF 10. It will go to CUCM and DC, which is also in part of VRF 10, right? Something like this. So you will have same services across the branch and the DC, and you will be able to segregate the traffic according to those services.
But Rajiv, this is the tunneling mechanism is done by the controller, right?
No. So this is basically just a tag that is added by the router to identify the traffic of different VRF. So in the legacy routers, the VRF tags were not extended across your PE router, across your C router. Once the packet leaves your customer edge router and goes to your PE, there was no VRF over there. Everything was in the single VRF. But in SD-WAN now we are extending that over the overlay tunnel from our branch to our DC and vice versa. So we are just extending the segmentation across your transport for segregating the traffic. That's it. So you don't need to, yeah, you don't need whatever policies are applicable for VRF 10. The same policies will be applicable for VRF 10 across the branch and across the DC, right?
So Rajiv, you want to say that, let's see, on branch side, I segregate my traffic into 5 parts. So it will going to create the 5 tunnels according to that segregation.
Tunnel will be one. There is one single tunnel. It is one single IPsec tunnel, but the traffic will be going along with the tag value of that particular VRF. So you will be able to distinguish the traffic between VRF 10 and 20, which is received in the same IPsec tunnel. Just like a trunk, you create a trunk port channel, and we have a VLAN 10, VLAN 20 tags to it. So when the switch receives the traffic, it sees the tag and then it sends the traffic in that particular VLAN only. Similarly, now SD-WAN is allowing you to extend your VRF tags within your IPsec tunnels. So this diagram is a bit misleading. It says that there are 3 different tunnels, but it is not 3 different tunnels. It is one single IPsec tunnel, but it is carrying the traffic of different VRF with a tag.
Okay. So also, Rajiv, I request, can you give
Everyone
us?
is able to get this, guys? What is the concept of end-to-end secure segmentation? So guest traffic, voice traffic, data traffic, critical traffic, everything can be segregated on per VRF basis or per VPN basis.
So Rajiv, can we take break for 5 or 10 minutes? I believe if all are agree.
Yeah, we just passed over 1 hour.
Because I
Let us
came
take
from the
a
night
short break.
shift actually. So
Sure.
what?
So after secure segmentation, the next advantage we have with Cisco SD-WAN is arbitrary VPN topologies. So Cisco SD-WAN supports the concept of logical overlay topology. Now, what is logical overlay topology? So for different types of VPNs that we have in our network, we can create different types of overlay topology. For example, my VPN 1 is being used for voice traffic. So for voice traffic, I want a full mesh. Branch to branch, branch to DC, all the traffic of voice should go directly. So for voice VPN, I am using VPN ID 1. And for voice traffic, I have kept the full mesh overlay topology. For VPN 2, I have configured hub and spoke. So VPN 2, I am using it for my critical DC application. So my critical DC traffic is, my critical applications are hosted in my DC. So I'm using a VPN 2 for it, and I'm using hub and spoke topology. I'm using my VPN 4 for my DC DR backup purpose. So between DC and DR, I'm having my backup of different applications done using my VPN 4. So I'm using a point-to-point topology and so on. So Cisco SD-WAN allows you to create a logical overlay topology for creating the IPsec tunnels. You can decide how do you want the IPsec tunnels to be created. Do you want the IPsec tunnels to be created in a full mesh? Do you want the tunnels to be configured in a hub and spoke way or a point-to-point way? And from SD-WAN version 20.3 onwards, Cisco has also started supporting the concept of on-demand tunnel, on-demand IPsec tunnels. So whenever the traffic will be initiated, then the tunnel will get created. Once the traffic is stopped, the tunnel will again break down, right? So this is the new feature which was not available when this slide was being developed. So it's not over here, but we do have the support of on-demand IPsec tunnels as well. So along with existing overlay topology, hub and spoke, full mesh, partial mesh, point-to-point, we do have the concept of IPsec tunnels as well. And these tunnels and these overlay topologies will be created on per VPN basis. So physically, there will be one single IPsec tunnel within the infrastructure. So if I try to show you guys how it will look like. So if this is my 4 branches or 4 locations, there will be one single IPsec tunnel created. And within that IPsec tunnel, the traffic for the particular VPN will go according to the topology. So for example, for VPN 1, you have a full mesh. So VPN 1 will be running across all the tunnels. My traffic of VPN 1 will go across all the tunnels, all the branches. VPN 2 is running in hub and spoke, for example. So VPN 2 will go like this. Hub and spoke topology. All branches will connect to the hub location. VPN 3 is point to point. So VPN 3 will run only between 2 locations. So within that IPsec tunnel, we are basically creating a logical overlay topology on per VPN basis, right? So tunnel will be one, but the traffic of different VPNs will go on per tunnel basis, per VPN basis, right? So this is another functionality which is available in Cisco SD-WAN. You can choose what type of overlay topology you want on per VPN, per VRF basis. Cisco SD-WAN also supports the concept of branch security. Now, one of the important use case of SD-WAN is using internet as a transport, right? You are basically trying to use your internet connectivity as a transport, which means that if this is your branch router, branch has got one MPLS link and one internet link, right? So you want your branch router to use your internet and MPLS both, right? Now on top of internet, I will create an IPsec tunnel to communicate with my DC router. On top of MPLS also, I'm creating an IPsec tunnel to communicate with my DC router, okay? Now, once you configure IPsec tunnel over your internet and over your MPLS, you also want the traffic of Facebook, Google, YouTube from the branch to directly exit on the local internet, right? I don't want the traffic of Facebook and YouTube to go over IPsec tunnel to my DC and from there to exit on the open internet. I want to take the advantage of local internet breakout, sending the traffic on the internet directly instead of sending it over the IPsec tunnel. The traffic of Facebook, YouTube, and Google should locally go on the local internet connectivity, which means that I'm exposing this internet to my branch router, right? When I'm exposing my internet to the branch router, I also want to have security. Now, I cannot afford to have a firewall over here. It's practically not possible to have a firewall at each and every branch location. So how do you provide security to your branch routers for DIA, for direct internet access? The answer to this is using branch security. So Cisco SD-WAN supports the concept of IPS, URL filtering, application-aware firewalling, AMP functionality, and DNS and Cisco umbrella integration for DNS layer enforcement. So all these features which were until now available on the firewall are now made available on the branch or are now made available on the routers itself. So your router can now do IPS. It can verify the signatures of the different applications and websites which are being accessed. It can do URL filtering. You can create a whitelist, a blacklist to block the certain URLs. You can do application aware firewall. Only certain applications or certain websites will be accessible from the branch. It can do AMP, advanced malware protection. So when you're downloading any files from the internet, it can verify for any viruses, for any malwares, and it can block the application or block the file. You can integrate your Cisco SD-WAN with Cisco umbrella for DNS layer enforcement. So while trying to resolve the DNS itself, the website will be blocked or the DNS will not get resolved by integrating your umbrella solution with Cisco SD-WAN for avoiding the phishing attacks, right? So all these things are now available on your Cisco SD-WAN solution, which means that even if you're using your branch routers with open internet as a transport and for DIA, you can leverage the advantage of security on your router and you can ensure the branches are completely safe while exposing them to open internet as well.
Okay,
For
Raju,
this,
one question.
yeah, yes.
Raju, how do we know the Cisco router, it can support this much policies or this much rule or filtering? What is the power? What's to say? I think forget the word for that.
You basically are talking about the hardware capabilities of the device, right?
Yeah, right.
So that is basically available on the data sheet of the router. That is also in my slides as well. When we will discuss about the branch securities in detail in the upcoming slides, I will tell you the exact hardware requirement and the models which support these features, right? So there are selected models in ISR 1K and 4K which support branch security, and they also require certain amount of hardware, like they require 8 GB of memory and 8 GB of boot flash. Along with that, the right licenses are also required for the branch router to support the security functionalities, right? So I will
it's mean there is a benchmark is available. Okay, this Cisco router can support this much user and that much load of the policy or something, right?
Correct. It's available in the data sheet for every router, how many number of tunnels are supported, how many number of routing table is supported, and all those details. You can check it on the data sheet, and also I do have a list of devices which are supporting this security features.
Okay.
All right. Next, we do support the concept of service-based insertion. So you can, this is another feature we have in Cisco SD-WAN where you can reroute the traffic from one location to another location through an intermediate firewall. So for example, my user is sitting in the branch. Let us say on this branch, I don't have any security features. Okay. My user is sitting in this branch and I have like 100 users, or not 100 users, that is a very big number for the branch. Let us say I have 50 users. I have 50 users in my branch. And out of this 50 users, only selected users are allowed to access the application in my DC. Okay. So maybe my branch manager, my assistant branch manager, my TL, some of the users are allowed to access a particular application which is hosted in DC. But I don't have any security features available in the branch router. So currently what is happening is all these 50 users are trying to access the application. The traffic is coming to my data center, and then my data center firewall is verifying the user and then dropping the traffic for the users which are not allowed, which are not permitted, and only the permitted users are allowed to access the application. But this is basically utilizing my resources at my DC. So my traffic of 50 users is coming all the way to the DC, and then it is getting dropped out. So my MPLS link is getting overutilized. My router is processing the data. My firewall is processing the data for all those users. And my branch is somewhere in Mumbai. My data center is somewhere in Singapore, right? And there is a lot of traffic coming from Mumbai to Singapore, and finally it is getting dropped. And I don't want the traffic to come to Singapore all the way. So what I can do? I can configure service insertion. I can configure a policy such that I have a regional hub location in India. So within India, my regional hub location is in Bangalore, for example. So what I will say is, whenever the traffic is coming from Mumbai, for the application of my DC 10.1.10.10, the traffic should be rerouted through the Bangalore firewall. So traffic will come from the branch. Instead of directly going to Singapore, it will first go to my regional hub location. Over here, I have a firewall where I have filtered out the traffic, and only the traffic of authenticated or authorized users will go to the Singapore location. So this way, I will first of all save a lot of bandwidth consumption, resource consumption at my data center head and router. Secondly, all the traffic will be locally dropped, right? So nothing is being sent to Singapore. No unnecessary traffic is being sent to my hub location or to my DC location. All traffic will be filtered out locally via my regional hub. So this kind of policy is known as service insertion in SD-WAN. So you can configure a service insertion policy where you can reroute the traffic through a load balancer or through a firewall, and you can do the necessary filtering and configure the exact policies so that your head end router does not, or your DC head end router does not get overutilized in terms of bandwidth and other resources, right? So we can configure this kind of policy as well. This is another feature available in your Cisco SD-WAN. Cisco SD-WAN is also a cloud-ready WAN solution. So basically, you can host your applications on AWS or Azure. You can host a virtual router on AWS and Azure. You can create a secure IPsec tunnel over there as well. So for accessing the applications on Azure, which was until now done over an open internet. So if your branch is, let me delete this. So for example, this is my branch router, and currently my branch router is accessing the application on AWS cloud. So this branch is connected via MPLS. It is connected to my DC. DC is connected to AWS via internet. Okay, and DC is also connected to AWS via Direct Connect. Direct Connect is a private link from AWS, very similar to a private MPLS connection. So let us say I have an application in my AWS cloud, which was until now accessed via branch. Traffic used to go on MPLS. From MPLS, it used to go on DC. And then from DC Direct Connect, it used to go on AWS. Okay. Now with Cisco SD-WAN, what you can do is you can spin up a Cisco router over here, a virtual router of Cisco CSR 1K. This is a Cisco SD-WAN router. And from branch, you can connect to this Cisco SD-WAN router on AWS using internet as a transport. You can build a secure IPsec tunnel like this directly. So the branches can access the AWS applications over a secure IPsec tunnel without backhauling the traffic from your data center, right? So Cisco is also a cloud-ready WAN solution. You can spin up the virtual routers of Cisco on AWS or on Azure or on Google Cloud Platform. And once the router is spinned up over there successfully, you can create a secure IPsec tunnel over internet to the cloud router, and you can reroute the traffic of your branches to the AWS applications directly. So no need to backhaul the traffic from DC. You can now reach the applications on AWS directly, right? So this is another advantage we have with Cisco SD-WAN. One more advantage we have with Cisco SD-WAN is for SaaS, right? So if you're having your applications on Office 365, or you're having your applications on Salesforce, you're having your applications of XYZ, there are approximately 20 applications supported by Cisco. If a branch user is trying to access application of Office 365 or Salesforce, and let us say branch has got two internet. One internet is from Reliance Jio, another internet is from let us say BSNL, right? Cisco, I'm sorry, India's government link. So I've got two internet links, and Office 365 is reachable via both the internet links from this branch. Now, which link is the better performance? Which is giving me the better performance? How do I calculate this? So for this, Cisco SD-WAN supports cloud on ramp for SaaS, for software as a service. So if you're having any applications like Office 365 or Salesforce, Cisco router will send probes. It will send a kind of a hello packet to reach to this Office 365 application, right? And will verify which link is giving the better performance. And whichever link is giving you the better performance, the traffic of the branch user will be sent via that particular link, right? So this is the inbuilt functionality available in Cisco SD-WAN. We call it as cloud on ramp for SaaS. So what your SD-WAN router will do is it will constantly send probes like a hello packet to calculate the best performance to reach out to that particular application. And whichever service provider is giving you the better performance, that service provider will be automatically chosen by the branch router to send the traffic for that SaaS application, right? So Cisco SD-WAN is a cloud-ready WAN solution where it supports a cloud on ramp for IaaS, infrastructure as a service. Also, it supports cloud on ramp for SaaS applications. So this is another functionality available with SD-WAN. Cisco cloud routers are not configured with CLI anymore. So with Cisco SD-WAN solution, the routers are now configured using template-based approach. So we can configure templates for the routers and reuse the same templates for multiple routers at the same time. So you don't need to configure each and every router manually like we did in our legacy routers. In legacy routers, what we did was we had like 100 routers. So we used to go on each and every router and do the configuration via CLI, right? And this was a repetitive configuration. So now these type of configurations are no more required. We can design a template. These templates can be configured according to the category of sites. For example, I can, if I have like 1000 sites, I can categorize the sites on the basis of transport. Like all the sites with 2 MPLS is one category. All the sites with 1 MPLS and 1 internet is one category. All the sites with only 1 internet or 1 transport is one category. So I will design a template for 2 MPLS sites. I will design a template for 1 MPLS, 1 internet site. And I will design a template for the sites which have only 1 transport. And then these templates will be pushed automatically to those routers upon doing the device onboarding. So when the concept of plug and play functionality is done, when I'm trying to use the concept of plug and play and the router gets onboarded, the corresponding template will automatically get pushed on that router. So no need to do the repetitive configuration again and again from the routers. You can use the concept of template-based approach to configure the routers and onboard the devices automatically, right? So we will be doing this particular lab as well, how to configure the routers using the template-based approach. A very wonderful thing for configuring your routers and doing the management from a centralized approach. Cisco SD-WAN supports the concept of application and flow visibility, which we have spoken about. So you can see, we can actually verify how much amount of traffic is going from the router. So you are having Google traffic, Twitter traffic, Facebook traffic, BBC News, YouTube, CNN. Which source is utilizing how much amount of bandwidth? Which transport is being utilized how much? So if I have 2 transports, let us say internet transport of Jio and internet transport of Airtel, then what is the amount of traffic going on internet, what is the amount of traffic going on MPLS, and so on. You can verify everything on your Cisco SD-WAN router, right? So it gives you a complete application level visibility, traffic level visibility, flow visibility as well, right? This is possible because of the functionality of deep packet inspection. Simplified management on one single dashboard. You will be able to configure everything. You will be able to verify the utilization. Cisco SD-WAN supports REST APIs, so you can integrate your controller using REST API with your third-party tools. You can use netconf for configuration and push as well using REST API. We have syslog SNMP exporting your flows. You can configure the things via CLI as well. So we have multiple ways of doing the monitoring and management for Cisco SD-WAN solution. This is like consolidating all the features in one single slide. So Cisco SD-WAN is a transport independent solution. It supports routing functionality, security functionality, end-to-end segmentation, supports QoS, multicast, service insertion, high availability. From application point of view, it supports application visibility, SLA-based management. You can do traffic engineering, per segment overlay topology, integrate your firewall services in Cisco SD-WAN, supports cloud integrations as well. And apart from that, it provides you a single dashboard for operation management and traffic visibility, right? So that's like one single slide of consolidation with regards to the features supported by Cisco SD-WAN. All right, so that's about the features, guys. What are the different functions and features of Cisco SD-WAN? Just to summarize everything quickly on one single whiteboard. So whatever we have discussed, we started the discussion of features and advantages. We have end-to-end segmentation. So you can just try to make a note of it. I can put it down on the notepad instead. So features of Cisco SD-WAN. What are the different features we have with Cisco SD-WAN? We have end-to-end segmentation. We have bandwidth augmentation. We have zero-touch provisioning, ZTP or plug-and-play functionality. We have per VPN overlay topology. We have on-demand tunnels. Transport independent solution. We support QoS, multicast. We have branch security features, that is IPS, AMP, URL filtering, DNS layer enforcement using umbrella integration, application firewall, right? Apart from this, we do support voice as well. Voice integration, we can configure voice on Cisco SD-WAN. It was not a part of this slide deck. It's a new functionality added in 19.0 onwards. We will discuss that during the upcoming topic, right? So these are some of the advantages and features. And of course, then we have single dashboard management, simplified control plane, right? So these are some of the features which we have with regards to Cisco SD-WAN as a solution. Any questions from anyone, guys, with regards to the different features that we have discussed so far? So these slides, I'm going to share it with you. You guys can use it later for your reference as well. And then come back to me if you have any questions, right? One more advantage I can add is DPI and application visibility. SLA based transport selection. All right, let us now go ahead and discuss about the architecture of Cisco SD-WAN. So far what we have discussed is we have discussed
Rajib,
about
sorry to cut. I mean, for if I'm using any controller, so is there any limitation that how much devices it can support? I mean, the branch devices or something?
No, there is no such numeric limitation in terms of the number of routers which are supported. As of now, what I have done, Currently, I have done a maximum deployment of 2000 plus branches on Cisco SD-WAN for one of the banks in India. So there is no such limitation in terms of the numbers with regards to maximum number of routers that can be onboarded on our solution. So as we keep on increasing the number of routers, what we have is we increase the number of tunnel count. And with the number of tunnels being increased, we have to increase the number of controllers, right? So it is inversely directly proportional. More number of routers is equal to more number of tunnels. More number of tunnels is equal to more number of controllers, right? That's how it is. But there is
And
no such limitation in the number of routers that can be participating in the fabric.
and is there any recommendation from Cisco like they do for ACI that minimum 3 epic controllers should be there? Like,
Yes, we do have a recommendation. So let me just discuss this topic of
yeah, sure,
different types of controllers,
no,
and
no worries.
I'll discuss about how we do HA in controller as well.
Sure.
Okay, so talking about the architecture of Cisco SD-WAN, everyone. So far we have just discussed about what are the features we have in Cisco SD-WAN and why Cisco SD-WAN is different, and the advantage of Cisco SD-WAN over the other OEMs, right? For example, there are multiple OEMs which do not support multicast. There are some OEMs which do not have voice integration support. There are OEMs which do not have the concept of on-demand tunneling. Um, we do have advantage of end-to-end segmentation, again not available with certain vendors. Branch security, again not available with certain vendors. So there are multiple advantages with Cisco SD-WAN as compared to different vendors. Of course, we do have some limitations which are advantage in the other OEMs as well. But then we always talk about our best part and not the worst part, right? So talking about the architecture of Cisco SD-WAN. Now, Cisco SD-WAN has got is basically we are segregating the control plane and the management plane out of the device. So this is how our legacy architecture looks like. Every router will have their own management plane, have their own control plane, and have their own data plane. But in Cisco SD-WAN, we are abstracting the management plane and we are abstracting the control plane out of the device. So where are we exactly placing the control plane and management plane? We are placing it on a separate controller. So there are 3 different types of controllers available in Cisco SD-WAN. The controllers are known as vManage. We have something known as a vManage controller. We have vBond controller, and we have vSmart controller. So there are 3 types of controllers available in Cisco SD-WAN. We have vManage controller, vSmart controller, and vBond controller. Now, all these 3 controllers are software controllers. All these 3 controllers are software controllers. They are not hardware controller. They are software controller. So we do not have any hardware for this. Okay. Cisco SD-WAN deals with software controllers only. These controllers can be spinned up as a virtual machine either on customer premises, or you can spin this on Cisco Cloud. There are 2 options to spin up the controllers. If the customer is coming from a BFSI sector or from a defense sector or from a government sector, then customer will say that we want to spin up the controllers on our own premises because of security reasons and their internal reasons, right? And if the customer is coming from anywhere outside this, like it's a corporate customer, a corporate office, or a particular organization, XYZ organization, then they can also spin up the controllers on cloud. So you have an option to choose from whether you want these controllers to be running on a Cisco on a Cisco cloud, or the customer wants to spin up the controllers on their own internal data center in their own premises, right? Now, what is the job of these controllers? Why do we use these controllers? So as the name itself suggests, the first controller we will talk about is, the first controller we will talk about is the vManage controller. So what is vManage? vManage is a management plane. So vManage basically provides you the dashboard for configuration and management of your entire SD-WAN fabric. vManage is the only controller who provides you the dashboard. So there is no dashboard given by vSmart or vBond. Okay, vManage is the controller which provides you the dashboard. So from this dashboard, you're going to configure the templates, you're going to configure the policies, you're going to do your monitoring, you're going to do your troubleshooting, you're going to do your daily operations, right? So the dashboard which is given for Cisco SD-WAN is basically provided by a vManage controller. So vManage controller will be the controller where you're going to log in from your laptop or from your jump server, and you're going to do all the configurations. So it's a single pane of glass where you're going to do your device onboarding. Your router will be onboarded on the vManage controller, and your daily activities like configuring your policies, templates, doing your troubleshooting, monitoring, performing your software upgrades, etc. Everything will be done via vManage controller. So the status of your fabric, right? All your routers will be visible inside your vManage controller. All your devices will be visible inside your vManage controller, and your vBond and your vSmart also will be visible inside your vManage controller. So vManage is basically your single pane of glass from where you are going to do all the configuration and management. Now, vManage is a software controller, right? vManage is a software controller. Like I mentioned, we do not have any hardware for vManage. Okay, so vManage is a purely a software-based controller, and you can choose to deploy the vManage either on your cloud, or you can choose to spin up your vManage on premises. So depending on how the customer is looking forward to spin up the VM, right? For example, Cisco allows you to spin up the vManage controller on premises for 3 different kinds of hypervisors. So if I go on Cisco software downloads, let me go on Cisco software downloads. 1 second.
Rajiv,
Yes.
these controllers can be run over the Cisco UCS, right? No, not on any other
Server.
server.
No. Server can be anything. It can be a
Anything.
Cisco server. Yes,
It
hardware
can be
can be
anything.
anything.
Okay.
Cisco software downloads, vManage. Okay, so that's basically the place from where you can download the controllers, Cisco Software Central. And here, if I come on vManage, all right, so you can see if I go to a particular release, the latest version is 20.5. Cisco recommendation is 20.3. So you can see here we have a file to download a OVA file, a QCOW image. Why is it not showing one more category? Let me go for an older version. Oh, okay, it looks like they have stopped. Yeah, it's available over here. So you can see there are 3 different types of hypervisors which are currently supported for deploying the controller on premises. So for example, if a customer says that we don't want the controller on Cisco cloud, okay, we want the controller in our internal data center, then you can download the controller file. It's a OVA file for VMware, a QCOW image for Linux, and a tar.gz file for Microsoft Hyper-V. So hardware can be anything. It can be a Cisco UCS, it can be Dell server, Dell HP server, or it can be IBM server or any other server. On top of that server, you will run your hypervisor. You can run a VMware ESXi, a KVM hypervisor, or Microsoft Hyper-V, and you can download accordingly the file, and you can run the virtual machine, right? So there are 3 different options for deploying the controllers on premises. If a customer is willing to deploy the controller on premises, if customer is happy with running the controller on cloud, which is what the Cisco SME is going to recommend. Okay, so if you ask Cisco what is the best practice and what is the best way to run the controller, they will always recommend to run the controller on Cisco cloud, right, without any additional cost added to it. So if you are running it on Cisco cloud, then Cisco will give you 2 options. Either you can run on AWS, Cisco AWS Azure account, or Cisco Azure cloud, right? So you can run it either on AWS or Azure, 2 options to choose from, without any additional cost. So Cisco will run your controllers dedicatedly for your organization on AWS or Azure, which will be accessible over public network, over open internet, right? And if you are willing to run the controllers on premises, then you can also run the controllers on premises, and you can make it reachable via MPLS or via internet as well, right? So there are two options to deploy the controllers. That is, either you can deploy it on premises or on cloud. And currently what I have done is, in my setup, I have run the controller on 20.0.0.1.0.5. So currently I have spinned up a vManage controller on my server. I am basically using a VMware ESXi host to run the controller. Oops. Okay, so here you can see I have spinned up my controller over here. That's the vManage controller. So I'm running it as a virtual machine on my VMware ESXi. And this is the console of the VM, which I have spinned up already. I'm running the version 20.1.2, right? So you can simply download the OVA file of the VM, and you can run it as a virtual machine. We will see that in the later part of the class as well. And I can just log in on the vManage dashboard and show it to you guys as well, how it looks like. I have given the IP of 20.0.0.9. That's the IP address. No, it's not. What is the IP address? Let me log in. So this is basically spinned up for this training. I have configured the IP of 21.1.10. Okay. Oops. 1 second, guys. I got disconnected. Okay, sorry. Yeah, so that's the vManage controller dashboard that I have spinned up. And if I just log in over here, so that's the landing page of Cisco vManage controller. And inside this, you will be basically having your other controllers registered. So you can see your vSmart, your vBond, and your WAN edge routers. Everything will be basically registered inside the vManage dashboard. So from vManage, you will be able to do the configuration and management of the rest of the network. You don't have any dashboard for the other controllers. The dashboard is only available for vManage controller. And from vManage, you are going to basically configure and manage the rest of the network. Is that clear to everyone, guys? What is the use of vManage controller? So vManage is your management plane. After vManage, the second controller we have is the vSmart controller. So vSmart is basically your control plane. vSmart is your control plane, and from vSmart you are going to basically do your routing. So vManage is for management plane, vSmart is for control plane. So all the routers which are going to be onboarded on the network, they are going to basically communicate with the vSmart using DTLS connection. So they are going to talk to vManage for getting the configuration, monitoring, troubleshoot, operations, right? So they are going to connect to the vManage controller for configuration, management, troubleshoot, and operations. They're going to communicate with the vSmart for getting the routing updates. So every router will connect to vManage and vSmart. From vManage, it will get the configurations pushed. From vSmart, I will get the routing updates. So whatever routes I have on my side, I will advertise it to the vSmart controller using OMP protocol, overlay management protocol, which will run inside this DTLS tunnel. And every router will repeat this process. So every router will talk to vSmart for advertising the routes and for receiving the routes. So vSmart acts like a BGP route reflector. This will act like a route reflector clients, and this will act like a BGP route reflector server. So all the routers They will not communicate with each other directly for exchanging the routes. They are going to go and talk to the vSmart, and vSmart will be receiving the routes from all the routers and then advertising the routes to the other routers as well, right? And then we can configure policies for controlling the route advertisement. So if you don't want certain routes to be advertised from one branch to another branch, or you want to aggregate the routes, you want to summarize the routes, you want to advertise a default route, blah, blah, blah. All those things will be done using your vSmart controller from vManage dashboard. So you will not access the vSmart directly. You will go in vManage. Over here, you will configure the policy. This policy will be pushed to the vSmart, and then vSmart will further push the policy to the rest of the network. So vManage and vSmart also will talk to each other using DTLS connection. Is this clear to everyone, guys?
So vManage is just only used for onboarding of the routers, like branch routers or the
onboarding, configuration, management, everything will be done from the vManage.
Yeah. So once it is done, so branch routers are only coordinate with the vSmart in further
for routing
further.
purposes. Correct. But then again, configuration and everything will be still done via vManage, right? So vManage plays a very important role, because whatever policies you want to configure, whatever templates you want to configure, everything will be inside your vManage, right? vSmart is just used for receiving the routes and publishing the routes on the network.
So I mean, you earlier said that whenever a branch device get the IP address, it first look for a controller, that is vManage.
No. That is a third controller, vBond. I will come to that. That is a third controller.
Okay.
For onboarding, right? That is third controller. There is a question in the chat. So vSmart will have another IP. That's right, Mathura. Every controller will have its own IP address. Every controller instance will have its own IP address. So for example, vManage is having the IP of 20.00.10. vSmart is having the IP of 20.0.0.8. Similarly, the third controller we will talk about now will have its own IP address. So every controller will have its own unique IP addresses on the network, right? And every router will have a DTLS connection for control plane with each and every controller hosted on the network. So vSmart is also a software controller. It is used for fabric discovery. When I say facilitates fabric discovery, means what? Whenever a new router joins the fabric, vSmart will advertise the information about the other routers part of the network. So from vSmart, I will receive the routes of the other routers, which are already registered on the network. And that's how your edge routers will communicate, will form the IPsec tunnel with the other routers. So once a router successfully registers on the network, it registers on the vManager on the vSmart. For example, these routers, router 1, 2, 3, 4, and 5 are already registered on the vSmart. Okay. And now I'm registering a new router, router X. So as soon as I register router X on the network, router X will advertise its own routes to the vSmart. And then vSmart will advertise the routes of these other routers to router X. So router X will receive the routes of router 1, 2, 3, 4, and 5. And I will know that there are 5 other routers in the network. And once I receive the routes from the vSmart, then I will create the IPsec tunnels with these routers directly. So vSmart helps you to facilitate the fabric discovery. It helps you to register the router on the fabric by advertising the routes of the network. It is used for, it is basically acting as your control plane controller. It is used for advertising the routes, for managing the policies. So all the routing policies will be basically taken care by the vSmart controller. For redundancy, we will deploy multiple vSmarts on the network, right? So for redundancy, we deploy multiple vManage on the network. For redundancy, we also deploy multiple vSmarts on the network. If you want the controller to be reachable via public and private network both. Private network means MPLS and P2P. Public network means your 4G or internet and your broadband connections. In that case, you will have to configure a static public IP for your controllers, right? So you can configure a private IP on the controller, and then you can do the NAT of that IP address on your internet firewall or on your DC firewall. So if you want if the controllers are on premises, okay, if the controllers are on premises, So this is your server. On this server, you deploy your vManage, you deploy your vSmart, and they are getting connected to the top of the rack switch. From there, they are getting connected to the core switch. From core switch, it is getting connected to your aggregation router, and it's getting connected to MPLS. And then another leg from the core switch is going to your internet router. It is going to internet firewall and going to internet. Now there is a branch. There is a branch which is only connected to internet. So how will this branch router communicate with the controller? Because controllers are on premises, and this branch router does not have MPLS. So it cannot communicate via MPLS backhaul, which means that this controllers will also require a public IP. So you can configure the public IP address and do the static NAT for that IP address over here on your firewall. For the private IPs, you will publish the public IPs and you will advertise those public IPs on the open internet. And now the branch router which has got internet will talk to these controllers over the public IP, come to our internet firewall, internet router, core switch, and after that it will go and talk to the private IPs, right? So if your controllers are on premises, then you have to make them reachable via MPLS as well as via internet. Is that clear to everyone, guys? Any questions, anyone?
Yes, Rajiv.
Yeah.
It means once you install or locate the controller at the customer premises, you need to configure the static IP address with the public IP address.
Correct. For the NAT, to make the controllers reachable over internet. If there is no requirement of making the controllers reachable over public network, then there is no NATing required. If you want the controllers only to be reachable via private network of MPLS, then there is no NATing required. But if you want the controllers to be reachable via public internet as well, for internet only sites, if the customer has got the sites where there is no MPLS, there is only backhaul internet, there is only MPLS backbone network. I'm sorry, I'm saying it the other way. If a customer has got a site where there is no MPLS, there is only internet, then for that, the controllers need to be made reachable via internet. And for that, you will have to do a static NAT for those controllers.
Okay, but I don't think so. Netting is always required.
I'm sorry, I did not get your point.
Why we need a netting?
You cannot configure a public IP directly on the controller over here, right? Otherwise, how will they be reachable via MPLS?
No, I'm talking about this controller and communication through the internet.
So private
I'm not
IPs,
talking about the private IP addresses.
So Mir, when you deploy the controller, okay, now these controllers will have IP address from your MPLS service provider network, whatever segment you are using on your MPLS private network. From that segment, you will assign a pool, and from this pool, you will assign one IP each. So 10.1.1.2 is my vManage, .3 is my vSmart. Now these IPs, you cannot advertise these IPs on the internet, right? These are private IPs. So if you want the controller to be reachable over internet, you require a public IP address for this corresponding private IP. So how are you going to configure those public IPs on the internet? You will have to do a NAT on the firewall and advertise those public IPs on the internet.
No, I mean we can use the public IP address instead of the private IP address.
On the controller itself?
Yes.
Over here.
You know what's the challenge?
So how will you
are going for the IPv6 cases? There's no concept of the netting.
That's right. That's right. So see this. If you configure a public IP over here directly, then you will have to do a reverse NAT for that public IP to get advertised on the MPLS network. Either way, you got the point. If you configure a public IP, then that public IP needs to be advertised on your MPLS network, so that the routers which are connected to MPLS can reach out to that public IP address via MPLS network. Or if it's a private IP, then you'll have to do the NAT on the firewall. In either of the cases, you will have to either advertise your public IPs on the on the MPLS network, which is 99.99% of times not done, because you will not have the public IP segment inside your data center network all the way on your inside network, right? So you never configure a public IP on your internal network. You always have private IPs over there. So in most of the cases, as a best practice, you will configure a private IP and do a static NAT of that private IP on the firewall to make it reachable over public internet. But if you have configured a public IP, then that public IP needs to be advertised in your MPLS network to make it reachable via MPLS backbone.
Okay.
Got it? These are the two options. These are the two options which are possible. If you configure a public IP, advertise it in MPLS. If you configure a private IP, then do a NAT of that in the firewall.
Okay.
Clear,
Also, I
guys?
think it is a cost saving purpose to give the private range instead of purchasing 3 or 4 public IPs. Take one public IP on the firewall and configure NAT. It is also cost saving.
No, but still, if you configure NAT, it is a static NAT, Devinder. So Cisco does not recommend you to do a PAT. It will always ask you to do a static NAT. So it will be one-to-one NAT for each of the private IP addresses.
Okay, so I need 3 public IPs over there.
At least 3, yeah, at least 3.
Okay.
For each controller, 1 for each controller.
I have a question here.
Yeah, you need a /29 subnet.
That depends, Mir, depending on how many controllers you have. So if you have redundancy with controllers, you might require more number of IPs as well, like multiple vSmarts, multiple vBond, multiple vManage. So more number of IPs will be required. So it varies from customer to customer.
Yeah, but it's if we are going for the IPv4 cases, so the world is right now the shortage of the IPv6 cases. So ultimately we move to the IPv6.
You can also configure IPv6. You can also configure IPv6 on the controller. We do support IPv6 as well. So if you are having a customer who has already got IPv6 on the network, then you can do IPv6 deployment, or you can do IPv6 to IPv4 NAT as well. Even that is possible. Yes,
yeah,
Ravi.
That's I think a little bit difficult for the netting.
Yeah, we are doing it. We are doing it for Geo right now. So Geo is already running on IPv6. So we are doing that IPv6 to IPv4 for Geo.
Actually, that's called that's basically right now the best practice is the dual stack, where we are using both stacks, IPv4 and IPv6. That's called where we are convert from IPv4 to IPv6. That called the CGNet. Carrier grade netting we required. This is quite challenging, and
So,
there are many cases the DNS resolution has been an issue.
Yeah,
Anyhow, this is a different topic. Anyhow,
to summarize, the controllers, if you are deploying it on premises, then you have a choice to configure a private IP and do a NAT to a public IP, or you configure a public IP and then advertise it in MPLS for MPLS only sites. If it's on cloud, then you don't need to worry about anything. Cisco will deploy the controllers for you on AWS, and you will get a public IP address for that controllers, which you can make it reachable for the sites which have internet access. They can directly talk to the controllers. For the sites who have only MPLS, then they can backhaul to the controllers via DC internet. Right? So there are 2 possibilities for this. IPv4 and IPv6, I think we can leave that topic aside for now.
Yeah, right. Okay.
Yeah, Rajiv. Yes. Yeah, my question was related to can you go to the diagram on the left side? No, the same diagram.
Yeah.
Yeah, here, like you said, we have a controller in the connecting to internet. One is sorry, not controller, that a router connecting to internet, another router connecting to MPLS. So as per my understanding from the previous slide you showed, where the router to router will be an tunnel, right? They will be forming IPsec tunnel.
Correct.
Right. So these V edges, if I'm not wrong, these will be the V edges, right? They will be.
These are the branch routers. Yeah.
Yeah. So in that case, if I'm not wrong, this router have a internet connectivity. It's facing to the public. It have a public IP address, right? And the other router have a MPLS provider, yes, IP address, which can be the our internal, the private IP address, right? In that case, also where we somewhere we have to configure the net, or it will be taken care by the vManager.
So there will not be any tunnels from router to router for MPLS and internet. So
okay,
because this is a private network, private transport, and this is on public network, public transport. So between MPLS and internet sites, you cannot have a direct communication. This communication will happen via backhaul of DC. There is a branch of MPLS only, and there is a branch of internet only. So these routes will not get propagated directly. You will not have IPsec tunnel directly. So you will have to talk via internet. The traffic will come to internet router, core switch, and from here again the traffic will go out like.
Okay.
We will have SD-WAN router over here as well, which will basically take care about the communication for MPLS to internet sites. You will not have a direct IPsec tunnel over there.
Okay, so here SD-WAN router will be. I thought the SD-WAN router will be in the campus or will be at the branch side, right?
Even DC will have an SD-WAN router, right?
Okay.
Data center side also we will deploy an SD-WAN router.
Yes.
So this router will have connections like this IPsec tunnel. This IPsec tunnel will come via MPLS to DC hub location, and then communication will go via hub.
Okay. Got it, yeah.
We will see this scenario in the upcoming lectures. I will discuss about how the traffic movement happens between branch to branch via hub location.
Sure. Okay.
All right. So that's about the vSmart controller, guys. The next controller we have is the vBond controller. So vBond is your orchestration plane, and it's basically the gatekeeper or the watchman. So what is the job of vBond now? vBond is the controller who is responsible for plug and play functionality in SD-WAN. So if you remember, I told you whenever a new router is being onboarded, okay, I'm having a branch router which needs to be onboarded. Now this branch router will, as soon as you power on the router, this branch router has got a bootstrap file in which we have a bootstrap config done for Cisco devicehelper.cisco.com. So this devicehelper.cisco.com is basically nothing but your vBond controller. So as soon as you power on your router, the router will first go to the vBond controller. vBond will authenticate the router. vBond will authenticate the router. It will verify the certificate of the router, the serial number of the router. And upon successful authentication, vBond will give the information of vManage and vSmart. And then the router will go to vManage, it will go to vSmart and establish the connection. So the router will never go to vSmart and vManage directly unless it successfully authenticates itself to the vBond. So vBond is kind of a watchman. Just like when you are going to your office, when we enter our premises, we have a security guard who will verify the identity of our us. It will take a look at our ID card and we'll see that we belong to this company, we belong to this organization, and we are allowed to enter the premises. Similarly, whenever a new router is being onboarded, these routers will always first go to the vBond using the bootstrap configuration. They will always first go to the vBond. vBond will authenticate the router based on the serial number of the router and the certificates of the router. And once the router is authenticated, then vBond will share the information of vManage and vSmart. And once I get the information of vManage and vSmart, then the router will go and talk to vManage and vSmart. Is that clear to everyone? The job of vBond is to orchestrate your network, that is automatic device onboarding, help you to onboard the device automatically using the concept of plug and play.
So Rajiv, this DNS what is this helper.cisco.com? It seems to be not hardcoded to any company. So let's say there are two companies and they are onboarding the same routers on the same time. They are reaching to the vBond. Then how would
they don't go to vBond. We will talk about that as well. So this DNS resolves to Cisco's TNP portal. Okay. And from there, Cisco will be aware of that this router is being purchased by, let us say, Infosys. So the controller, so the request will go to Infosys vBond. This router is being purchased via, let us say, AT&T. So the router will go to AT&T vBond and so on. So it does not go to vBond directly. It goes to Cisco's portal. And Cisco knows that this serial number belongs to which organization. And accordingly, it gets forwarded to that organization's vBond controller only. Okay.
Thank you.
We will talk about that entire plug and play process, how plug and play exactly works. It's a very interesting one, but you got it right. So this is a public DNS, like it's open DNS for Cisco's portal, and then Cisco's portal redirects the request to that particular organization's vBond. Okay.
So Rajiv, it is quite challenging. Many countries, they are not allowing to go any information outside.
Correct. So for that case, if a particular, so for example, like again, coming back to the same, if it's a BFSI sector or if it's a defense or army or government organization, they do not allow you to go on open internet. They do not expose the router to open internet. In that case, you will have to manually configure the vBond IP over here on the router. While configuring the static IP, along with static IP, we also manually configure the vBond IP. So router does not go to PNP portal. It looks at the vBond IP and directly goes to the vBond. Right? That is the alternate way of doing it. If you are not allowed to talk to the online PNP portal account.
Yeah, many times we have the refurbished router also. I think in that case, this is the
best approach. Yeah,
that's it.
You can manually configure the vBond IP on the router and send it to the vBond directly instead of PNP portal of Cisco.
Okay.
Another question in the chat. Yeah, sorry. Go ahead, Amir.
Okay, it means you have to, before configure the vBond, you have to configure the many things inside your router also.
Yeah, so first you will set up the vBond, and then you will come onto your router and tell the vBond IP address to the router.
Yeah.
Your vBond needs to be in place before we tell router who is the vBond.
That's okay. Okay.
Yeah. Another question in the chat from Mathura. Is it again a DTLS connection between Yes, it's a DTLS connection, Mathura. So the first connection which initiates, right, that is not a DTLS connection. It will be an open HTTPS request from the router. It will be a standard request going to the PNP portal. From PNP portal, I will get the vBond IP, and then I will communicate with the vBond on a open network. But once vBond authenticates me, then a DTLS connection will be established. And on that DTLS connection, I will basically share my vManage and vSmart list. Okay. So before authentication, there is no DTLS connection. After authentication, it is a DTLS communication. Is that clear, Mathura? Yeah. All right. All right. So the job of vBond, guys, vBond is your orchestrator. It basically helps you to automatically onboard the edge routers by authenticating the routers against the serial number and the certificates. And once the router is authenticated, vBond will share the information of vSmart and vManage, and then the routers will get onboarded successfully. So these are the three different types of controller, guys. Okay. We have three controllers in our Cisco SD-WAN. That is vManage for management plane, vSmart for control plane, and vBond for orchestration plane. Everyone is clear with the controllers, and these controllers can be deployed. These are all software controllers, first of all, and these can be either deployed on premises or you can deploy them on cloud. If you deploy them on cloud, it will be Cisco AWS or Cisco Azure Cloud. If it is on premises, you can deploy them on KVM, Hyper-V, and ESXi, VMware ESXi. Everyone is clear with the controllers, guys? Any questions on the controller part? So right now, as you can see on my server, I have deployed the controllers. Oh, I got logged out. So I have deployed all the three controllers over here. You can see I have deployed a vManage, a vSmart, and a vBond. So I have deployed one instance of each. And once you deploy the controllers, you do the configuration, which we are going to talk about that shortly. And then you can access the dashboard over here. Okay. All right. So coming back to the next one. So after your controllers, the last one is your data plane traffic. And your data plane traffic is basically your edge routers, right? So control plane, management plane, orchestration plane is your controllers. Your data traffic is with the edge routers. Now the edge routers in Cisco SD-WAN can be categorized into two platforms. The edge routers in Cisco SD-WAN can be categorized into two platforms. We have something known as a V-edge and C-edge. V-edge are nothing but Viptela routers, the original organization which was acquired by Cisco. C-edges are nothing but Cisco routers, which we have been working since ages. So when you are buying Cisco SD-WAN as a solution, you have a choice. Either you can buy a Cisco C-edge or you can buy a Cisco V-edge, right? Cisco will strongly push you to buy a C-edge router for obvious reasons. Cisco wants to sell their own hardware. They don't want to sell Viptela hardware. Secondly, the development on Viptela is stopped. There is no further development happening on Viptela routers. Cisco is slowly trying to push back Viptela routers, and they are slowly like basically there is no development anymore happening on Viptela. There is no internal team working on Viptela operating system anymore. Whatever updates, whatever we have with Viptela OS is now on a standstill, and Cisco only has got the development of BU happening on C edges now. So there is no BU for Viptela operating system anymore. Whatever updates we have, that is in place. No more updates on Viptela, right? So tomorrow, if you're going to buy Cisco SD-WAN, you will always buy a Cisco C edge. You will never buy a Cisco V edge router. Okay, but just for your information and just for understanding, we have V edges. In V edges, we have different models. We have V edge 100, we have V edge 1000, we have V edge 2000 series of routers, we have V edge 5000 series of routers. In C edges, we have Cisco ISR 1Ks, we have ISR 4K routers, we have ASR 1K routers, we have CSR routers, we have Catalyst 8000 series as well, right? There are different types of C edge routers and different types of V edge routers. V edge routers will run Viptela operating system. V edge routers will run Viptela operating system, and C edge routers will run iOS XE image, iOS XE SD-WAN images, right? Your controllers also run Viptela OS. So your vBond, vSmart, and vBond and vManage also run Viptela operating system. Okay, and your C edge routers will run iOS XE. Your V edge routers will also run Viptela operating system. So there are two types of families for edge routers. First, we have V edge router. So we have V edge 100, 100M, MW. This is basically for a very small location, small office, home office, or a ATM location, or a location with less than 10 users or so on. Then we have V edge 1000, V edge 2000, and V edge 5000. This is for medium branches, like anywhere between 10 to 20 users or 10 to 50 users. V edge 5000 is for DC DR location or a hub location, right? So it supports up to 6000 IPsec tunnels. This guy supports up to 1500 IPsec tunnels. It has got 8 ports of 1 gig up to 1 gig. Here we have 4 ports of up to 1 gig and 8 ports, 2 ports of 10 gig as well. Here we have 4 ports of 10 gig, 8 ports of 1 gig, and so on. Maximum throughput is 20 Gbps. Maximum throughput is 10 Gbps. Maximum throughput is 1 Gbps. But like I said, VH is now, it's not yet announced, but it is going to be announced. It will be very soon. It will be end of sale. And then also Cisco might do end of life probably next year. No more support of VHs. So you will basically buy C-edge routers, right? In C-edge, we have ISR 1K, ISR 4K, ASR 1000 series. ISR 1K is for branch routers, small office, home office, and branch routers. ISR 4K is for hub locations, and ASR 1K is for DCDR locations, right? And that's a complete product family of SD-WAN routers. Now, again, this is also old. This is also old. The new series we have is Cisco Catalyst 8K SD-WAN. So these are the new platforms for SD-WAN family, guys. So going ahead, if you talk to Cisco Cisco will actually tell you to buy Catalyst 8000 edge routers. So these are specifically designed for Cisco SD-WAN again. We have different models over here. We have 8000 virtual router, which is basically a replacement for CSR 1000V. We have Catalyst 8200, Catalyst 8300. This is a replacement for ISR 4K. And we have Catalyst 8500, which is a replacement for ASR 1K. So if you ask me, the latest supported and the latest models of routers which are recommended by Cisco, then this is what Cisco will recommend, right? So gradually we are also now moving from ASR and ISR to Catalyst 8K platform. Is that clear to everyone, guys?
Yeah, Rajiv.
Yeah.
Sorry, I have one question.
Yeah, go ahead, Ravi.
Okay, so my question is, suppose I have already ISR or maybe one ASR in my environment, ASR 1002 or ISR 4K. So, and I want to deploy SD-WAN. Can I use the same router? Do I have to buy some license, or there is another iOS?
You will have to upgrade the software, and you will have to buy the license. Two things are required.
The same software, like if I'm running iOS XE 16.12 somewhere, or do I have to? Is there any if I compare with ACI, we have an XOS mode and ACI mode, right?
Correct.
So yeah, so is there the similar way we have here, or it's something that it's an entire different iOS?
No. That is basically depends on what version you are running. So before 16.2.x, we had a different image of SD-WAN and non-SD-WAN. Okay. So if you are running iOS XE below 16.2, then we had a different image for SD-WAN and non-SD-WAN. But if you are running your ASR on 17.x onwards, we have a single image for SD-WAN and non-SD-WAN. You can just use one command: controller mode enable and controller mode disable. Okay. So if you are running iOS XE above 17.x, then you can convert the same image into controller mode, which means SD-WAN mode. Disable means it will become non-SD-WAN standalone router. But if you're running below 17.x up to 16.2, then there is a different image altogether for non-SD-WAN and SD-WAN.
Got it. Thank you.
Got it?
Yeah, thank you.
So Rajiv, these edge devices are also providing the WAN optimization, or do we need VAS or something?
You need explicit VAS services. There is no inbuilt VAS functionality. But if you have a virtual VAS or you have a hardware VAS appliance, you can integrate it with Cisco SD-WAN.
Okay, thank you.
There was one more question from Mir, I guess.
Yes, Rajiv.
Yeah.
Actually, you see the Catalyst 8200, there's a mention, and one is mentioned 8200 UCP. What is the difference?
Yeah, I'm coming to. So UCP is basically a server plus router. This guy will basically have a memory, storage, CPU, on which you are going to run the virtual instances of firewalls or virtual instances of load balancers, virtual instances of VAS. At the same time, it will also have the router capabilities. So it will have the physical ports of routers to connect it to your edge locations, right? So UCP is basically a NFV functionality of Cisco SD-WAN, where you can run this router along with SD-WAN functionalities. You can run the virtual instances of different functions like firewall or a load balancer or a VAS for the branch location. So if you have a remote location, okay, where you do not have a physical firewall or physical load balancer, but you want to get those functionalities for that location, then you can buy a Catalyst 8200 UCPE. That router will act as Catalyst will act as a router. Plus, it will provide you the server's functionality to run the virtual instances of firewall, and you can get those features as well for that location. So it is for a remote location.
So Rajiv, this means I can run the third-party applications also.
You can run third-party applications. Yes, you can run
only for this device firewall. Because the universal CPE concept is like that. It's just like a white box. You can run
white box only for virtual instances. So you can run a virtual instance of Palo Alto firewall on this, load balancer of F5 big IP on this. But the router will be from Cisco. The hypervisor will be given by Cisco, on which you can run your virtual instances of any vendor.
Okay.
There is something in the chat window from Winshit. Can we run both legacy and non-SD-WAN on? No, Winshit. It can be either of one. So like I mentioned, if you're running an image of above 17.x release of iOS XE, then you can choose whether you want to run the router in SD-WAN mode or non-SD-WAN mode. Okay. And if you are running below 16, below 17, then you have to upgrade the image. Okay. 1 second, guys. I'm getting a call. 1 second, please. Sorry. All right. Sorry for that. There's another question in the chat from Mathura. Can I choose Catalyst 8500 for non-SD-WAN? Yes, yes, of course. You can use Catalyst 8500 as a non-SD-WAN device itself. If not, if you don't want to use it for SD-WAN, that's absolutely fine.
Okay, Raji, one more question.
Mm-hmm.
Can we categorize Cisco router like SD-WAN router, universal CPE, and virtual CPE? Is there any category where we can say or no?
We do have virtual. No, I did not get your question completely, Mir. Can you reframe it?
Yeah, if you go for the SD-WAN world, I think there are the three concepts. There's the one called virtual CPE.
Mm-hmm.
Another one is called the universal CPE, which is I told you that
this one is the same virtual router which can run on AWS or on premises for a hypervisor. So if you're having a AWS, if you're having your applications running on AWS, okay, and now you want that AWS cloud to be connected to your on-premises SD-WAN, and you want to communicate with AWS over a secure IPsec tunnel, then this virtual instance can run as a router on AWS cloud or on Azure cloud or on Google cloud. And this one is UCP is basically when you want a particular remote location to be connected to SD-WAN. At the same time, you want to run some NFVs on that particular for that particular location as well. Okay, so these are two different things. This is basically for network function virtualization, and this one is where you just want to run a virtual instance of Catalyst 8K router for connecting to your physical branches.
So it means when we are using controller enable command, so we can say the Catalyst switch 8000, just make it SD-WAN router, right?
Correct. And if you run controller mode disabled, then it will be running as a non-SD-WAN router. All right. Okay. So that's about the edge devices, guys. That's about the different types of edge devices we have. Let us take a break. We have passed another 1 hour of. Okay. So the next topic we have is installation and deployment of the controllers. Okay. So like I mentioned, controllers can be either deployed on cloud, deployed on Cisco cloud, or they can be deployed on premises. There are two ways to deploy the controllers, either on Cisco cloud, or you can deploy it on premises. Now, if you are planning to deploy the controllers on cloud, then you do not need to worry about anything. Okay. If you're deploying the controllers on cloud, then you can just provide the deal ID and the smart account, virtual account details of your customer to Cisco. And Cisco will basically verify the deal ID, and then cloud operations team from Cisco will spin up the controllers on the cloud for this particular smart account, virtual account. So your job is done. You don't need to worry about anything. But if you are deploying the controllers But if you are deploying the controllers on premises, then there is something to worry about. If you are deploying the controllers on premises, then you will have to basically spin up the controllers yourself, which means you will have to choose from this list that we just took a look at. You have to select what type of hypervisor you are going to go with. You'll have to discuss about the sizing of the controllers. What will be the sizing of the controller? How many controller instances you're going to deploy? What will be the reachability? What will be the HA? What will be the redundancy? How you are going to make the reachability for the controllers and everything, right? So if your controllers are on cloud, then Cisco is going to take care about everything. Backup of the controller, HA, high availability of the controller, and availability of the controller. If you're deploying it on Cisco cloud, then controllers will be available 99.9999 times, right? Which means there is no downtime if the controllers are on cloud. The backups will be taken regularly by Cisco for your controller, so you don't need to worry about the backup, about the availability, nothing. But if the controllers are going to be deployed on premises, then you yourself will be responsible for the configuration and management of the controllers, right? So before that, you have to deploy the controllers. So how do you start the process? Where do you start it from? So right now I'm going to talk about the minimum setup, that is one vManage, one vSmart, and one vBond. How do you start from the basic? So first of all, you're going to select the hypervisor, obviously. You can choose any one hypervisor from the list of options. You can either choose VMware ESXi, Linux KVM, or Microsoft Hyper-V. Once the hypervisor is finalized, now you can download the image for that particular hypervisor. So let us say you download an image for OVA file for VMware hypervisor. So once you download the, let me increase this. Once you download the OVA file, you can basically run it as a virtual machine. So for example, on this particular, okay, not on this. Let me go on my jump server. Okay, so if I go on my jump server, and here if I open downloads, do I have OVA file? I don't have any OVA file right now to show you guys, but you can simply download the OVA file. Once you download the OVA file, you can go in your, I'm really sorry guys, 1 second. Let me stop sharing and share the full screen. This is very annoying. Okay, it's much better. So once you download the controller, now you can log in your hypervisor. Go to your hypervisor and log in on your ESXi host. And here you will click on spin up a virtual machine. So click on virtual machines, create or register a virtual machine. Here you will select the option of deploy a virtual machine. Click on next. Select the file, select the OVA file. So you should have an OVA file to deploy. Right now I don't have an OVA file over here. But once you have an OVA file, you can just select the OVA file and you click on next. It will automatically take the details. It will automatically select the storage, the memory, the CPU. Everything will be picked up dynamically, right? So you don't need to worry about providing the how much CPU, how much memory, and how much storage is required. It will pick up the size automatically depending on what OVA you are trying to spin up, right? So if I come to this here, also I do have it. So select this. You go in your vManage, go in your ESXi, select the OVA file. Once you select the OVA file, it is going to automatically select the storage, the memory, and everything. You don't need to worry about how much memory and how much storage to provide to the virtual machine. The sizing will be taken automatically. One thing to make a note of is when you're deploying your vManage controller, when you're deploying your vManage controller instance, you will require an additional hard disk. So for vManage controller, you will have 2 hard disks for the virtual machine. One hard disk will be required for installing the VM, and the second hard disk will be required for storing your configuration. So whatever configuration, whatever DPI data and etc is being stored, All those details will be basically stored on the second hard disk. So one hard disk will be required while for installing the virtual machine itself, for processing the VM itself. And the second hard disk will be used as a storage for storing your data. So when you're installing your vManage virtual machine, you will have to always ensure that you have a second hard disk added inside your VM when you're deploying the file. And how you can add the hard disk? You can just click on add a new hard disk over here, and a new hard disk will be added. Change the size to 500 GB for production environment. Okay. In production environment, you will have a second hard disk of 500 GB. Primary hard disk will be taken by default of 20 GB. Memory will be automatically taken as 32 GB. CPU will be by default taken as 2 CPUs. You can increase these to 4 CPUs for a better performance, right? Apart from this, your virtual machine will require 2 network adapters. One network adapter will be required for management access, and the second network adapter will be required for your tunnel configuration, for your tunnel reachability. So when you're deploying your virtual machine, this is your VM of vManage, you will have 2 network adapters. One network adapter will be connected to your management VLAN, and the other network adapter will be connected to your MPLS VLAN, right? Whichever VLAN is being used for providing you the MPLS reachability, one adapter will belong to that particular VLAN, and one network adapter will be required for management access, for Telnet, SSH, SNMP, NTP, etc., etc. You will require management access. So one interface will be in management VLAN, and the other interface will be in your MPLS VLAN. Is this clear to everyone, guys? Does anyone have any question on this part? Anyone who did not understand this? Everyone is clear on this?
Can you repeat it for me?
Yeah. So basically what I'll be trying to do is, I will show a bigger picture. This is your server, physical server. On this server, you are running a virtual machine of vManage. Okay. This server will be getting connected to your top of the rack switch, maybe a 3850. This will be a trunk port. This will be a trunk interface. On this trunk port, you are going to trunk 2 VLANs. You will trunk your management VLAN, whatever is your management MGMT VLAN. And you are also going to trunk your MPLS VLAN. So this virtual machine of vManage needs to basically communicate towards your MPLS network, right? It needs to be reachable over MPLS, core switch, aggregation router, MPLS backbone, right? So your branch routers, which are connected via MPLS, this branch router will communicate with this vManage controller over this MPLS connection. So here on this virtual machine, when you're connecting this virtual machine, you will have 2 interfaces. One interface will belong to your management VLAN, let us say VLAN 10, which is your management VLAN. Another interface will be your MPLS VLAN, a VLAN which you are using for MPLS reachability. So for example, VLAN 103. So VLAN 103 is basically is in the segment of 10.1.30.0/28, which is basically providing me the IP addresses which are published in my MPLS network. So one port will be part of MPLS VLAN, another port will be part of management VLAN. Let us say 10.0.0.0/24's network, which is my management VLAN network, right? So when you're spinning up the virtual machine, this virtual machine will have 2 network adapters. One network adapter will belong to your management VLAN network, and another network adapter will belong to your tunnel interface, MPLS network VLAN adapter.
Basically, these are virtual adapters, right?
These are virtual adapters of your VM. So this will be taken care by the
okay.
server team. Okay, you will not do this as a network engineer. You are not going to do this. You will just provide the OVF file to them, and you will tell them, I want one leg of my VM in management VLAN and one leg I want it in my MPLS VLAN. You will provide them the VLAN ID, and they will themselves do these configurations for you. Okay, so you don't need to worry about this. But just from understanding point of view, you should be aware that on your VM, you will have one leg in your management network and one leg in your tunnel interface VLAN.
So VLAN means port group in the language of
Correct.
VM.
In the request
Yeah.
of VMware. Correct.
Okay.
Anyone else? Any questions on this part, guys? Everyone is clear so far? Okay. Once you're done with this settings, once you are done the spinning up the VM, now you are going to log in inside the VM. So you will take the console access over here. So let us assume that my VM is spinned up. I have spinned up the virtual machine. Once the VM is spinned up, now you can take the console access of the VM. And inside the console access, you are going to do some basic configuration. Here you are going to do some basic configuration. So this is my vManage virtual machine. If I do show version, I'm running version 20.1.2, right? Once your VM is pinned up, now we will have to do some basic configuration. So the configuration of your controller, or for that matter, the configuration of SD-WAN is divided into three parts. There are three parts of configuration. We have system configuration, we have VPN 0 configuration, and we have VPN 512 configuration. So what is this? What is the system configuration, VPN 0 configuration, and VPN 512 configuration? System configuration is to basically identify this device. This device belongs to which organization, which site ID, what is the host name of the configuration. So under the system configuration, the different parameters that we configure is, we configure the host name, we configure the organization name, we configure the system IP address, we configure the site ID address, and we provide the vBond IP address. So once you spin up your vManage virtual machine, you will configure a host name for this virtual machine. Let us say the host name is vManage _ Cisco. Organization name or host name is vManage _ BLR, Bangalore, DC. So this vManage belongs to Bangalore, DC. vManage 1, Bangalore, DC. Organization name will be basically unique name which will be used to identify your organization globally on Cisco's network. So basically you are basically registering your devices and you're registering your controllers on Cisco PNP portal, Cisco Smart Account. Okay, so on Cisco Smart Account, once you buy the devices, Cisco will create a smart account for your organization. Typically, it is already configured and created for every organization, because every organization already has some devices. Now, this concept of smart account and virtual account was introduced by Cisco with the concept of smart licensing. The traditional licensing is now transitioning to smart licensing in Cisco, right? So for every organization, Cisco creates a smart account, and inside that smart account, Cisco creates a virtual account, right? If your organization does not have a smart account virtual account, then you can always go to your Cisco SE or Cisco SME, and you can request them to provide you a smart account and virtual account for your organization, where you are going to tie up the licenses of your devices. So all the devices will be registered with their licenses under your smart account virtual account. And for your smart account virtual account, you will get a unique organization name, which will be unique across the entire Cisco's PNP portal. So for example, if you belong to an organization, let us say your organization is State Bank of India. So Cisco will give you a unique organization name. Let us assume that it is State Bank of India. Now this is case sensitive. The whatever organization name is given to you by Cisco, you have to use the same organization name across all the devices which are registered in your Cisco SD-WAN fabric. So your controllers, your routers, everyone will have the same organization name, or more realistic name would be something like this, SBI underscore SD-WAN, right? Something like this. So Cisco will give you an organization name, or you can tell Cisco that this is the organization name which I want. So Cisco will give a unique organization name to your smart account, virtual account, which you are going to use it on your routers as well, on your controllers and your routers. Next, you will configure a system IP. System IP is just a router ID, just like we had a router ID in our network. Similarly, we have a system IP address. It can be any numeric value, need not be a routable IP address. It's not a routable IP address. It is just used for identifying the devices uniquely on the network. Okay, so you will configure a system IP. It can be any value. It can be 192 series, 172 series, 10 series, anything. Site ID, identifying each and every site. So for example, all the routers, all the controllers for my DC location, I will identify it with a site ID as 11111. Okay. Or if you want a realistic site ID, then typically what we do is we identify the site ID using the pin code. Especially in India, we have a pin code. Similarly, in other countries, in other states, we have area code or something like that. So you can configure site ID based on the area code or pin code. For example, in India, my for Bangalore location, it is 560100. So I will be able to understand that this controller is pinned up in Bangalore because this pin code belongs to Bangalore region, right? vBond IP address. So whatever vBond IP you are going to use while spinning up the vBond virtual machine, you will have to provide the vBond IP address. So this is a system configuration. This will be consistent across all the routers. So every router will have the same organization name. Every router will have the same vBond IP. The host name, system IP, and site ID will vary device to device, right? But this is basically my identity. This is basically my identification. I belong to which organization and what is my controller vBond IP address, right? After system configuration, the next thing is you can have site ID as, no, Mir, that will be your host name. You cannot use new alphabets in your site ID. It has to be a numeric value only. Okay.
So this site IP, system IP address is basically the internal IP address. If we have multiple vManage, then they will communicate with each other using this, right?
No. It's not a routable IP address. It's just for identity purposes. If you have multiple vManage, they will communicate via your tunnel interface.
And they should have different IP addresses.
Correct.
Right?
Correct.
Okay. Okay.
Yeah. And this is your. So after you configure your system, the next thing you will configure is your VPN 0 configuration. So VPN 0 is nothing but a tunnel VRF, which is dedicated ID. VPN 0 or this VPN ID 0 is dedicated by Cisco for tunnel interfaces. So on your router, whichever interface is going to participate in the tunnel, MPLS interface, internet interface. So these interface gig 00, gig 01, these are basically my tunnel interfaces. So these interfaces will belong to VPN 0. If you are running Viptela OS, they will be part of default VRF if you are running iOS XE. So the tunnel interfaces of your router will be part of VPN 0 if you are running Viptela operating system, and they'll be part of default VRF if you are running iOS XE. The management interface gig 0, which is belonging to your management VLAN, will be part of VPN 512 or VRF 512. So VRF 512, VRF ID 512 is reserved as a management VRF ID. And starting from VRF 1 to VRF 65536 is basically used for service VPN, or you can say LAN VRF. So there are predefined range. There are predefined range of VRFs in Cisco SD-WAN solution. I will draw it on whiteboard again. 1 second. So basically in Cisco SD-WAN, we have VRF VPN 0, VRF default, or VPN 0, which is your tunnel or transport VPN, on which you're going to create your IPsec tunnels. Then we have VPN or VRF 512, which is your management VRF. So on this VRF, whatever traffic will be received, it will be considered as my management out of band management traffic. And then we have VPN 1 or VRF 1 to 65536, which is your service VPN, or you call it as LAN VRF. So your data traffic will be part of this range. Voice traffic, critical applications, regular data traffic, everything will belong to this segment. Your LAN interface will belong to VRF 1, VRF 2, VRF 10, 20, or so on. Your management interface will become part of VRF 5 and 2. And your tunnel interfaces, your WAN interface, your WAN MPLS interface, or your WAN internet interface will belong to default VPN or default VRF or VPN 0. So as a part of configuration, over here on vManage VM, your vManage will basically have two interfaces. Your vManage will have two interfaces. So if I do show interface, what happened? Yeah. So if you see, I have got two interfaces. I have ETH0 and I have ETH1. I have two interfaces. ETH1 is my management interface, and it is part of VPN 512. Let me do a SSH instead of this. Very easy. 20.0.0.10. So if I say show interface pipe tab, you can see I have one interface in VPN 512, which is my management interface, and one interface is in VPN 0, which I'm using it for tunnel. Here you can see the type is transport. Here the type is management. So VPN 512 is used always for management purpose, and VPN 0 interface will be used for tunnel interface for transport communication. So as a part of configuration, when you are doing the initial configuration, you are going to basically configure your VPN 0 interface ETH1, for example. Here I will configure IP address 10.2.1.10/24, no shut. I will enter inside VPN 0, and then I will go in interface 1. I will configure IP address. I will define it as my tunnel interface. So I'm going to configure my DTLS tunnel using this interface, right? No shut exit, and then VPN 512 will be purely for management purpose. So you can simply configure any IP address over here of your choice. So here I can give a description, tunnel interface, and here I will give description, management interface. Right? So that's the bare minimum configuration required to set up your vManage controller. This is the minimum configuration required to set up the vManage controller. Once you do this configuration, once this configuration is done, now you can simply come in your web browser and you can try to access the dashboard of your vManage, and you should be able to access the dashboard. Let me minimize a bit. So now you come in your web browser. After you do this configuration, go to your web browser and punch in the management IP address of the vManage, and you will land yourself on the landing page, right? You will be basically able to log in inside your vManage controller. Is this clear to everyone, guys? What is the how to configure your vManage virtual machine for on-prem deployment? Now, this is required only if you're doing an on-prem deployment. If you're doing a cloud deployment, then these all things are done by Cisco. Your Cisco will do the basic configuration of the VM, and you will be able to directly log in on the dashboard. But if you're doing a on-prem deployment for a customer, then this is the minimum configuration that is required to be done. So here, if I say show running config, you can see this is my host name. My host name is vManage. This is my system IP. Site ID is 100. Organization name is Viptela SD-WAN. This is the tunnel interface IP address of my vBond. So vBond is having the tunnel interface IP of 1141. And then I have configured VPN 0. In that I have configured ETH1 IP address, tunnel interface IP address. I've configured it as a tunnel interface. Configure a default route towards my next hop. And then configure my VPN 512. That is also configured with IP address. And that's it. That's the configuration of my vManage. Once you do this configuration, you can come to your web browser, punch the management IP address, and you will get the vManage dashboard access. Anyone has got any questions on this, guys? How to set up your vManage VM? Any questions from anyone before I go to the next controller? All right. So after you are done with your vManage configuration, this is the system config, the VPN 0 config, VPN 512 config. After you're done with this, next you are going to come on your, one second, let me show you vSmart. Next you are going to come on your vSmart controller, right? Now we are going to come on your vSmart controller. How will we do the lab? Vinshit, are you asking about the lab spinning up the controllers? Or are you talking about the practice session?
Practicing this, any option to?
Yeah, I will give you access to the same setup, which I'm accessing right now. You will use the same setup. I have a lab guide and a topology as well. I will give you access to this lab, which I'm showing you right now.
Okay.
All right. The next controller you're going to spin up is your vSmart controller. So for vSmart also, you are going to repeat the same process. You will come in your SD-WAN, come to your SD-WAN downloads, Cisco software downloads, come to your vSmart. Here you will download your vSmart OVA file, come to your ESXi, spin up, click on register a new virtual machine. Same process, register a new virtual machine over here, and select the OVA file of vSmart, click on next, and your vSmart will be deployed. Again, on vSmart also, you will have one interface in tunnel, one NIC adapter in the tunnel interface. One NIC adapter will be part of the management VLAN. So even vSmart will require one for tunnel and one for management. Once that is done, on vSmart, you don't require any additional hard disk. So vSmart will by default choose one hard disk, memory, CPU. 2 network adapters will be required, of course. Once that is done, again come to vSmart and do the basic configuration. Configure your host name, configure your system configurations. You can see organization name will be consistent. So if I come to my jump host, and here if I take the access of my vSmart 20008, 20009, I think. Oh, this is vBond 20011. What is the config? What is the IP of vSmart? Let us just check quickly on the console. So that's my vSmart. Okay, it's 20007. So 20007 is your vSmart. So here also, if I do show running config, that's the system configuration that I have done. vSmart system IP, host name, site ID, vBond IP address, and then you will have your VPN 0 configuration, tunnel interface configuration on VPN 0 interface, and your management IP address configuration, right? With this minimum configuration, your vSmart also will be up and running. And then you can try to ping from vSmart, you can try to ping to your vBond. From here, you can try to ping, to your vManage 20.0.0.10, that is management reachability, VPN 512. And then the tunnel interface reachability 1.1.1.1 on VPN 0. So my vSmart is able to ping to my vManage on my tunnel interface, right? So your reachability is fine. And finally, you will come to your vBond. So on vBond also, you will do the same process. First of all, download the OVA file of the vBond controller. So you can come to your Cisco software downloads. For vBond, you will select the option of VH Cloud over here. Select the option of VH Cloud. Here you have an OVA file for vBond deployment. Download the OVA file, spin up the virtual machine. Once your virtual machine is spinned up, go to your console and do the basic configuration. So on vBond also, you will do the same config. Host name, site ID. Now here you can see I'm providing the vBond, the IP address, and then giving the keyword as local. What do you mean by local, guys, over here? Why am I giving the keyword of local?
Because it's not installed on any cloud.
No.
It's itself the vBond.
Yeah, because this guy itself is the vBond, right?
Okay.
This is the vBond machine itself. So locally, I'm giving the keyword local because I'm myself the vBond controller. So I'm telling my operating system that you yourself are the vBond controller. So this IP address of 1141 that is mentioned over here, you can see the same IP address is configured in my tunnel interface over here. This is my tunnel interface IP address, right? So I am myself the vBond controller, and this same IP I have given it to my vManage and my vSmart. So on my vManage and vSmart, I have mentioned the same IP address as a vBond IP. So here, if I say show run system, this is the vBond IP address. On vManage also, show run system, this is the vBond IP address, right? So I have told my vSmart and vManage that this is the vBond IP. And on the vBond, I have configured the IP under my tunnel interface, and I have given the local keyword. Everyone is clear so far, guys? So all the three virtual machines are configured now, correct? All the three virtual machines are configured with the base configuration. And what is the base configuration? So base configuration consists of, where is that?
So when this virtual machine boot up first time, then they will ask all these configuration, right? System configuration will be asked at that time.
It will not ask you. It will just boot up like a normal router, and then you need to configure this manually.
Got it. Okay.
Just like a normal router. A normal router boots up, you go in config mode. Just to show you guys, the CLI is very similar. So once it is booted up, okay, now you go in config mode. Under system, you will configure the host name. You will configure the system IP address. You will configure the site identifier, right? And then under VPN 0, here you will configure your ETH0 interface as your tunnel interface. And then under VPN 512, you will configure your management IP address, whatever interface it is. And then finally, you have to say commit. Finally, you have to give the code as commit. Commit is basically saving the configuration. It gets saved. Just like we had copy run start in Nexus OS or write command in iOS XE. Here we have the commit command. So commit will save your configuration. Unless you don't commit, the configurations will not get saved.
One more thing, like if I'm not wrong, in NCS platform of Cisco, if we don't do commit, it will not apply to the running configuration.
Correct.
Is it same here?
Same thing over here. It will not get applied unless you commit the changes.
To the running configuration as well.
Correct.
Right?
Correct.
Okay.
So you will not be able to ping that IP address because it is not yet applied on the interface.
Okay. Like on the other platform, we just configure it.
Yeah,
We
as soon
don't
as
need
you
to save.
configure,
Yeah.
even without
Yeah.
saving, it gets activated,
Yeah.
but
Yeah.
it's not the case over here. So unless you
Got it.
don't commit, it will not get applied on the running config and you will not be able to verify that configurations.
Got it. Thank you.
Clear to everyone, guys? Any questions on the basic configuration of the controllers, the system config, VPN 0 config, VPN 512 config? All right. So now that you have configured the controllers, next thing is to add the controllers in your vManage, right? Currently, if I go on my setup, you can already see that in my setup, I am able to, if I go on vManage dashboard, let us log in. For the very first time, when you are going to log in on your vManage, for the very first time when you're going to log in on your vManage, here you will see 0 vSmart, 0 Vanage, 0 vBond. You will only see one vManage up and running. You will not have any vBonds or any vSmarts or any edge routers. So how do you start the communication? Basically, after your controllers are spinned up, you want the controllers to communicate with each other, right? You want the controllers to establish secure DTLS connections among themselves and identify one another that we are part of the same SD-WAN fabric. So how do you start from there? How do you start from establishing the controller communication? So to establish the controller communication, you first need to come inside your vManage dashboard. After you are done with the basic configuration of all the controllers, you have configured your vManage, you have configured your vSmart and your vBond. Now you will come under your vManage dashboard, and here you will go in configuration tab, devices. You will come under configuration, devices. Under devices, you will come under controllers. And here you have an option of add the controller, right? So you will come under vManage dashboard. Under vManage dashboard, you will come under configuration tab, devices section. Under devices, click on controllers. And here you will click on add a controller. Click on vBond. It's going to ask you the IP address of the vBond. Now here it says, provide the management IP address of vBond, but this is incorrect. You will not provide the management IP address. You will provide your tunnel interface IP address. So although it says provide the management IP address, you will not provide management IP address. You will provide your tunnel interface IP address. So whatever is your vBond IP, 1.1.4.1 in my case, username, password, uncheck the option of generate a CSR. I will come back to this and click on add. It's saying it already exists because I have already added it. But for the first time, when you will click on add, your vBond will get added over here. Similarly, you will click on add controller and vSmart. Provide the vSmart IP address, username and password. Uncheck the CSR option and click on add. It will basically add the vSmart controller as well, right? So you will provide the details of your vSmart and your vBond. This IP address is not present in the network, I think. vSmart IP address is what? Show interface tab. So in your iOS XE, we have the command show IP interface brief. In Viptela OS, the command is show interface pipe tab. The corresponding command of show IP interface brief in Viptela operating system is show interface tab. It shows you the list of interface and the IP addresses. Yeah, it is 1121. Yeah, here it says it's timed out. It is already added basically over here. So my vBond, my vSmart are already added, right? So you add the controllers from this section. Now, once you add the controllers in the vManage dashboard, the controllers will not directly establish the secure DTLS connection. So coming back to this, what you are doing is you have your vManage, you have your vBond, and you have your vSmart. Okay, so you have done the basic configuration on the controllers. You have told your vManage that your vBond IP address is 1141. You have told your vSmart your vBond IP address is 1141. And your vBond has been told that you yourself are the vBond. right? And after this, you go in vManage dashboard and you add your vBond and vSmart over there. Now, after you add your vSmart and vBond in the vManage dashboard, these controllers will try to establish the control connections with each other, the DTLS connections with each other. But these DTLS connections will not get created. The DTLS connections will not get created because the controllers will not trust each other. The controllers will not trust each other. And they will not trust each other because they do not have a signed certificate, a signed identity certificate. So what is this signed identity certificate? Basically, every controller which you are spinning up, these controllers will have an identity certificate tied up with them. These controllers will have an identity certificate which is present inside the controller itself. But this identity certificate by default is not signed by any CA. This identity certificate is not signed by any CA. So after you spin up the controllers, the next job is to sign the identity certificates of the set of the controllers by a CA server, by a certificate authority, right? Let me just pause the recording.